Good morning. Good morning. If I could get folks to take their seats, we can get our program started. Thank you. Good morning. I'm Lisa Kutala, and I'm president of UNM Rainforest Innovations, and I want to welcome all of you here today for maybe our 10th Innovate New Mexico. I've lost count. We're going to have a great program today, and the format's a little bit different than past years. We're going to have panels in specific areas of technology, so look forward to all of that. I want to thank our sponsors for today's event, including the Arrowhead Center at New Mexico State University, the New Mexico Economic Development Department, Sandia National Laboratories, and the Feynman Center for Innovation at Los Alamos National Laboratory, Spaceport America, and the Federal Lab Consortium. This is truly a collaborative event involving all of our research institutions in the state of New Mexico, so we're very excited. Opening remarks are going to be provided by Nora Sackett, who leads the Office of Strategy, Science, and Technology in the New Mexico Economic Development Department as the director. Previously, Nora served for over 4 years in the Office of Governor Lujan Grisham, working closely with EDD on the rollout of numerous state economic development initiatives, including industry expansions, business growth and relocation, and film partner announcements. Born and raised in Albuquerque, Nora has worked closely with state leaders and policy experts in many fields, including economic development, education, media, aerospace, film, science, and public health. In her roles at EDD, she is working to support initiatives for advanced energy and aerospace projects, leading the rollout of New Mexico's C-PACE program, which enables property owners to finance energy efficiency and resiliency improvements, and expanding support for federal funding relevant to job growth and economic security. So let's welcome Nora Sackett.
Thank you, Lisa. Thank you so much for having me, and to the whole Innovate New Mexico team for being a wonderful partner for the state of New Mexico and for the Office of Strategy, Science, and Technology. I appreciate this opportunity to be here and hear about all the ideas and energy at this conference and celebrate New Mexico's innovation ecosystem. As Lisa said, my name is Nora Myers-Sackett, and I have the pleasure of serving as director of the Office of Strategy, Science, and Technology at the New Mexico Economic Development Department. Nice and short name. At its core, my job is anchored by optimism for New Mexico's future. And this is important because it's easy to talk about innovation in the past tense here in New Mexico. The Manhattan Project, recently highlighted in the award-winning Oppenheimer film, the advances in aerospace happening at Spaceport America, the many technologies that have evolved from science at the National Research Labs. All of this is important. It lays a foundation for New Mexico's success and explains why many of us are here today. But innovation is emerging on all fronts in New Mexico. It is alive and well and moving at speeds no one will anticipate in the coming decade. And what is just one example? Quantum. I know it may feel like the buzzword of the year, but for a good reason. Just as semiconductors and the internet transformed the last 50 years, quantum technology will define the next 50, unlocking solutions to everything from cancer cures to climate change corrections, with over $3.5 trillion projected annual economic impact. New Mexico has already been home to critical building blocks for quantum technologies in the form of the groundbreaking work being advanced at our national laboratories that are represented here today, and the world-class education in quantum physics happening at our state universities. In fact, the world's first quantum processor was built in Los Alamos in 1999. Our labs and universities have driven Nobel Prize-winning breakthroughs at the foundation of the quantum revolution. Now, we will build on that foundation and enter a new chapter that brings industry to the state and solidifies our role in the next chapter of quantum computing, while creating new jobs and spurring both scientific and economic growth. Just recently, Quantinuum, the world's largest integrated quantum computing company, announced that it is expanding into New Mexico and already hiring for their first positions. With the right investments as quantum transitions from scientific breakthrough to economic revolution, we will ensure New Mexico doesn't just invent the quantum future, but it owns it. But quantum technologies are just one example of the innovation being developed here in New Mexico. And I have to tell you, my job is really the coolest because every day I get to learn about new technology in climate tech or bioscience or aerospace that is being supported and grown right here in our backyard. At the Office of Strategy, Science, and Technology, we work to support that innovation and foster the growth of New Mexico businesses in science and tech. And I'd like to highlight a few of the things we're doing to make that happen. We are glad to support New Mexico startups with non-dilutive funding to catalyze their growth and commercialize their technologies. I am proud and grateful that in the last year, we have been able to dramatically increase, with the support of the governor's office and the legislature, in some cases doubling the amount of award funding that we provide for science and tech business startup grants and Phase 1 SBIR matching grants. We're also creating new award programs to meet identified needs. For example, we are grateful to have partnered with UNM Rainforest Innovations to administer 2 new awards, one for New Mexico startups in advanced energy and one to support New Mexico University faculty working to commercialize their new technologies. In just the first year of the Advanced Energy Award pilot program, the awardees have made incredible strides, including establishing a battery prototyping facility, completing and selling a water treatment prototype for produced water, and securing tens of millions of additional dollars in funds. And brand new this year at OSST is our Business Assistance Program. We're working with 5 contractors to provide sector-specific business assistance to New Mexico startups, some of whom are here today, I think. This is a new expansion of the kind of resources that OSST can provide and a direction that we hope to continue to grow in. And speaking of directions we're going in, we want to be sure that where we're headed is the right one. And we are taking the right path there, which is why we are working with 2 premier national firms to take a deep dive into New Mexico's science and tech industries. We are working with Techonomy Partners to answer the question of which science and tech sectors New Mexico is most competitive in and which levers we should be pulling to maximize opportunities in those sectors. And we're working with the Rocky Mountain Institute to take a deep dive into New Mexico's comparative advantage in advanced energy, including manufacturing, R&D, and energy generation and storage. We'll use this information to better inform our growth and to continue to guide the work we do with all of you, our ecosystem partners, and to drive innovation in New Mexico and create both jobs and scientific advancements, both of which go toward making better lives for New Mexico families. I look out here today and I see so many of those with ideas and technologies that are making society a better place with a more secure and prosperous future, from tackling climate change to breakthroughs in bioscience, healthcare, aerospace, engineering. So that is what today is about, coming together as a community and nurturing innovation that is happening right here in New Mexico so that what we do today can outlast us and improve the well-being of our children for generations to come. Now, for me to stop talking, which is good news for all of us, I'm excited to introduce our keynote speaker, someone my office has had the pleasure of working with. Dr. Mahmoud Taha earned his PhD in civil engineering from the University of Calgary and is a distinguished professor and Regents Lecturer in engineering at the University of New Mexico. With more than 25 years of experience in research and development, he brings a wealth of knowledge on using polymer materials and nanotechnology. He has over 350 publications and 14 issued U.S. patents. Dr. Taha is a fellow of the American Society of Civil Engineers, a fellow of the American Concrete Institute, didn't know that one existed before I read this bio, and a licensed professional engineer in the U.S. and Canada. He has served as a visiting professor in South Korea, Canada, and Cairo. Dr. Taha is the founder and CEO of TS-Nano, an energy and climate tech company manufacturing nano-modified polymer cement to seal abandoned oil and gas wells and mitigate methane emissions. TS-Nano has received several OSST grant awards, including as one of the inaugural awardees of the Advanced Energy Award pilot program, and we are very proud to see the advancement of their homegrown innovation. Please welcome Dr. Taha.
Thank you, Nora, for the very generous introduction. It's my pleasure to be here and to present about TS-Nano. Thanks for the invitation from UNM Rainforest. It's always a pleasure to work with UNM Rainforest and all the sponsors today, including New Mexico Economic Development, who's been supporting us a great deal, and of course, India National Lab, who I have the pleasure of working with through my 22 years as a faculty at the University of New Mexico. So if I can, I will present about this what we call as the TS-Nano, which is the name of our startup company, and my journey as a faculty entrepreneur. You will see that I will be combining a lot of what I do with what TS-Nano does, because really it is, for me, it's one thing. Let me start by talking a little bit about my journey as a faculty. As I said, I've been in North America. I'm originally from Egypt, if you wonder about the accent. And I've been in North America for 30 years. I did my PhD at the University of Calgary, and I lived there for about 8 years. And then 22 years ago, I joined the University of New Mexico and moved to New Mexico. You can see the picture there about my journey at UNM. On the far picture is when I joined at the University of New Mexico 22 years ago. As a faculty, having the opportunity, of course, of building research teams and opportunity to work with them. This is part of my team on the top left. This is really the soldiers who did all the work, and I always came and presented and took the credit. But they always have been a great team. And what I really learned working at UNM is that it takes really two to tango. And it takes a band to make a symphony. So I'm a strong believer that it's not a one-man show. It's actually how to build teams and how to look for talent and for people willing to do the work. On the bottom left here is some of my proud moment working with the Department of Orthopedics as work I did on the area of biomechanics. Great work did with this department for a while. And on the bottom right is I spent 9 years of my career at UNM as a department chair for UNM Civil and Construction Engineering. And in the middle is where everything coming to the TS-Nano team that I'm going to talk a little more about. Last year, I had the privilege and the pleasure to be named as UNM Innovation Fellow by Rainforest, and they developed a wonderful video about some of it. So I'm going to be sharing it through the slides and through the presentation a little bit about these videos that talks a little bit about what I do better than I present it again here. My name is Mahmoud Taha. I'm a distinguished professor in the Gerald May Department of Civil, Construction, and Environmental Engineering. My main research focus is how to actually get the typical construction materials to become more living elements. How can these materials have some sense type of self-sensing, self-healing, and recently we looked at how can we actually add to it some cognition such that these materials would be able to sense the fact it's aging or damaging, would be able to inform us about that, so we can interfere to improve the structural safety, resilience. And we also have been looking at how can we make these materials more sustainable, such that it would have good environmental impact and last longer for serving the purpose it's being used for. So that's what I did at UNM for the 22 years. But a little background about TS-Nano. How did it start, where it started? It's definitely a spin-off from the University of New Mexico. The technology we are using in the field today is 13 years in the making. It started in 2012, where I partnered with my colleague and CTO of TS-Nano and co-founder John Stormont. And we received a grant from the Department of Energy for developing very specialty sealant that can go in very thin microcracks for CO2 sequestration wells. And then in 2015, this was actually also some of our co-investigators were from Sandia National Laboratory, Dr. Ed Mateo. We worked together and we developed the material over the years, and in 2015, Sandia National Lab generously funded us for 3 more years on their LDRD, high risk, high reward research, which was significant for us to continue the development. In 2019, we successfully tested the technology. We were invited by this group of companies, Chevron, British Petroleum, Petrobras, and Total, to actually, they were testing materials in Switzerland. They have very sophisticated instrumented well in Switzerland. They invited 6 companies to come and bring their materials and test it. And to our surprise and happiness, TS-Nano was actually the company selected to proceed to the next phases. And we were strongly recommended by them to actually go and provide a commercial product. That's why we started TS-Nano in 2020. We found TS-Nano. We found it in February 2020, just about 1 month before COVID. It was an interesting hiccup, but it gave us some time to actually know exactly how are we going to move our work from the laboratory at the university to the field. As of today, we of course licensed our patents from that has been sponsored and supported by UNM Rainforest. But as of today, we have 5 licensed patents from our work to TS-Nano. The opportunity TS-Nano is looking at is the challenge. The challenge is the methane emissions. There is about 20 to 30 million estimated abandoned oil and gas wells in the world. 40% of them are continuously emitting methane. Our estimate is there is more than 50 million metric tons of equivalent CO2, because we use equivalent CO2 because you know that methane is about 20 times the harmless of CO2, and it is because of its impact with temperature. And the only way to actually drop the temperature quickly is to stop methane before stopping CO2. We also realized that the typical material used in the oil and gas industry is cement, and that is what the regulators worldwide is recommending to use to stop, to abandon the wells. And the problem was my experience, 30 years working on cement and polymers. Cement is a material that cracks, that degrades with time, that is not designed actually to stop gas. So that is the challenge and the opportunity we created in TS-Nano. So our technology is focused on 2 sides. The first side is what we develop, what we call as zonal isolation. Basically, the problem happens that the gas emits from the abandoned wells as they are opened, and also emits behind the casing. And that's actually a more dangerous case, that behind the casing, the cement cracks, and then with this, the gas emits. So what we needed to develop is to develop a technology for a nano-modified polymer that actually have special characteristics that can flow in extremely thin microcracks, can displace water, occupy its space, and stop the gas emission behind the cracks. And we successfully did this. We also realized that the industry, and as I said, the regulator requirement is using cement. So trying to change this will take decades. I think that's going to be beyond my time on Earth. So that's where we decided actually we are going to develop an unmodified polymer additive that can transform cement from that material into actually a material that is solid, that would not allow gas emission, impermeable. In the meantime, to be able to quantify how much gas going, we have to engage in monitoring the gas. There is a lot of monitoring technology worldwide. People monitor methane emissions worldwide using satellites. They use also drones. But none of these measurements actually tell you exactly how much methane is going out of the wells. So what we worked with companies on using a technology that's not ours, but we use it to actually quantify on the top of the well how much methane is exactly happening, coming out of these wells. And that allows us, when we seal the wells, to actually be able to generate carbon credits, because now you stopped this methane emission, especially if this is done by private investment. So the technology we develop is we basically manufacture at TS-Nano the nano-modified polymer formulations that can be used as a standalone material or can also be used as an additive to cement. We call it, it's a multi-scale material because we are manufacturing it at the nanoscale, formulating it, and then the material actually can be used to fill extremely thin microcracks. Some of these pictures here, you see this is microcracks below 10 micrometers, and we show that the fact that microfine cement cannot close it, but our material can close it and can flow through this extremely thin microcracks in very severe environment, high temperatures, high pressures. And then also it can be done at the macro scale where we can mix our material with cement to generate that next generation of cement, modified cement that can be used in abandoned wells. The technology for using in cement is simple. One of the biggest problems in cement is as a material that actually when it's in the liquid form, once the material, you put it in these cracks or you put it in the well, once the material starts to lose its hydrostatic pressure, transforming from a liquid to a solid, that is actually the chance for the gas to penetrate. I don't know how to give it back. Yeah, this is the chance for the gas to penetrate the cement and to get through. So what we do is our material is we transform the cement hydration and we block the gas going through during the time the gas typically go through. We've done this in the field. I'm going to talk about this in a few minutes. But the material we are now producing is much capable of coalescing against gas, high compressibility, it's elastic, and it's impermeable, and it also can resist high temperature, enabling us to actually go in a very wide range of oil and gas wells, from the standard wells at low temperatures to actually high thermal wells that's existing in northern Canada.
Economic side, because if we can help in reducing the methane emissions, that will allow us to stop the climate change, stop a lot of the changes that's affecting people's lives worldwide. The climate change is
This is
a
pictures
key problem
from TS-Nano.
we are trying to solve with the technology. So we developed specialty nanomaterials, nanomodified polymers specifically, to actually stop methane emission from abandoned oil and gas wells. We took this technology from the research lab. We started this technology 12 years ago. We took it from the research lab at UNM into a startup company at TS-Nano, where we actually successfully sealed so far 25 wells in the US and Canada, stopping methane emissions in these wells. Successful application of this at a large scale will definitely help in dropping methane emission globally.
So the business model we adopt at TS-Nano as a business is we call it a tripod, a unique tripod model, because we need to integrate our capabilities. The first one is to be able to monitor methane emissions from the top of the wells. And the second is to seal these wells. Some of it are wells that we call them orphaned wells because they do not have solvent operators. And some of them are wells working with operators as well. And in the case of orphaned wells, then that we will need to bring private capital to actually seal these wells, and then we can generate carbon credits for the fact that we did additionality to stop these methane emissions. Value proposition we bring is we believe we are really the next generation technology for a sustainable future in the area of the oil and gas. The most interesting thing in our value proposition is we really bring a scalable, cost-effective integration. Because oil and gas companies, because we are depending on the fact that they are using cement. We are using the same technology they use to actually reach at the bottom hole. So we do not change anything in the technology. Our material can be easily integrated in the current technology. That makes it scalable, and it makes it also low cost for them. So they do not need to change the procedure they are doing. They just need to use our material and implement it correctly to actually get, still can be able to produce oil and gas, but still stop all the methane emissions. We also help in the operators to meet the long-term compliance. We believe that when our material is used, can be sealing indefinitely. So they do not need to go. Usually, operators have to seal against methane emissions 4 or 5 times. And of course, we are adding an immediate value to both our investors and our customers. So part of the journey I have as a faculty, and part is the CEO, of course, now of TS-Nano since 2020. Now the changing gear as a CEO is this triangle I think all the time about, where of course, the top thing in the head of any CEO is investment. How can you secure enough investment to allow your company to grow, to allow to meet the challenges in the industry? The second part, of course, is the most important part is the team, recruiting and looking for talent. Because actually, as I said, I'm a strong believer that the team is what matters. The team is what will allow us to do that work. And of course, at the end, as a company, you have to be making revenue. You need to be making profit. So the market analysis, understanding the market, and of course, with all the political changes and the turmoils happening, understanding how can you navigate in this market. So far, we raised $2.5 million in private investment in TS-Nano. In the meantime, we have secured, here it says 2.1, we actually so far secured about $2.7 million of grants. Some of this is DOE grants that came to us to develop actually a new type of sealant. We do not have it in the commercial yet, and that meets, again, the ideas I had very early working on at UNM, which is making this material self-healing, so that if something happens in the material at any time, it have the capability to self-heal and to stop the emissions. And in addition to grants we received, of course, from New Mexico EDD, and we're very thankful for New Mexico EDD support. And we very recently, just this month, in February actually, received the $700,000 Canadian dollars grant to implement our technology in Alberta. So that's the latest grant for TS-Nano. We are at the moment raising $6 million as an investment in TS-Nano. Of course, in any meeting, I share this because if you know an investor, please let me know. This is the team we have now. We have 15 people total. TS-Nano today is the headquarters in Albuquerque. We are in the Biosciences Center in Albuquerque. That's where we manufacture our material. We have also a shop in Hubs, New Mexico, where we actually use it to deploy our materials in the field. And we actually have TS-Nano Canada, which is 100% subsidiary of TS-Nano, and that is in Calgary. So the team is between these 3 locations in the US and in Canada. You can see here in our operations, we have the monitoring, and we implement an AI technique to actually start relating the gas emissions and its patterns to the monitoring and the nature of the well and the information about the well. And this is our work in the field. You see Dr. Stormont is actually our CTO, and the one leading all our monitoring work. This is our field work in Canada. We've done work in Canada, and this is our field work in the Permian Basin. So we've been operating both in the Permian and in British Columbia and Alberta. As of today, by numbers, we have 7 patents. 5 of them is licensed from UNM Rainforest. We have 15 team members total. We have monitored so far for the state of New Mexico 70 wells, 70-something. Wells, and we are about to start monitoring a new group of 25 wells. We seal 35 wells today in both the US and Canada. We already applied 1,200 gallons of our materials in the ground in both the US and Canada. We have received $2.5 million of investment and $2.7 million of grants, and we generated so far about $820,000 in revenue. Our global presence, we are, as I said, in Calgary, and in, of course, Albuquerque is the headquarters and where we manufacture our material. We also just started talking with a partner in Australia. We expect that to kick off in Q2 to start with sealing our first wells. Australia is a very important customer to us because Australia has a zero emission requirements of their oil and gas wells. And that makes a big challenge for many companies, and that's where our material, we know, can work. We did work already for those companies, and there is others we are at the moment talking with to add them to our list of customers. We went around the globe in conferences and in shows presenting TS-Nano in the US and in Europe. And here, this is in 101. This is about an hour and a half from the US border with Alaska in Canada. So this was minus 40. And it doesn't matter, minus 40 Celsius or Fahrenheit, it's the same temperature. Nothing lives in this temperature. But that's in the field. Very successful job we did with ConocoPhillips in northern British Columbia. And again, we've been participating to talk about TS-Nano and have global opportunities. Last year in November, we actually won the second place in the Clean Tech National Competition that was held in Colorado. Very interesting competition. 12 companies were finalists out of 150 companies, and we were the winner of the second place. UNM recognized TS-Nano, it was on UNM website for a while, that as one of 5 technologies that come from UNM and can change the world, and we're very grateful and happy with this recognition by UNM. And in the middle, of course, we had a lot of fun. So this is our team. We were playing golf, and we are basically we're showing that we say no to methane.
Being at the University of New Mexico and the School of Engineering was an outstanding opportunity because it gives me a lot of freedom to select the research of interest to me and to follow the work I see of value. And I think I was a very lucky man to actually do the work that I consider as my hobby and then being paid for it. So the University of New Mexico and the UNM reinforced, and a lot of the facilities and opportunities created here in New Mexico helped me doing this. So I'm very thankful for that opportunity.
Thank you for your attention, and my pleasure to answer any questions. Easy questions, yeah?
What percentage is, do you know, actually contributing to the climate crisis? If you know the overall methane problem.
Yeah. Of course, I don't have the exact number, but I will tell you from experience. Our experience is first is it's a function of the place, location of the wells. Some of the wells in New Mexico have some reasonable size emissions. Some do not. Wells close to the East Coast, in the Appalachian area, in Ohio, some of them are extremely highly emitting to the point actually they will get the cattle dead around them. All the life around the well will be dead. Some of them in Canada similar. So the other interesting factor is you'll be surprised that in a platform where there is a dozen wells, 10 of them might not be emitting and 2 are extremely emitting. So there isn't a simple formula to know. The state of New Mexico has been having a plan to monitor for prioritizing the abandonment. So whatever is actually emitting higher, they would be trying to abandon it first than those emitting less. I think monitoring technology and monitoring is extremely important because without it, we wouldn't know. And what we're trying now to know is to answer the question better, is every well has a life history. And this is recorded, available, many of it. The well diagrams, some of them actually we know what is exactly down there. So we try to learn using AI with what features in the well, depth and type of rock formations and so on, would actually result in a higher emission and what will be the best solution for it.
Thank you.
Welcome.
Keep up the good work.
Will do.
Thank you for the talk. That was very fascinating. My question was, when applying the TS-Nano, do you have to, is it gravity fed? How intensive is the process to apply it into the wells? Are you guys having to use pressurized systems? And if that is the case, how difficult is that for places like, Alaska, where, the temperatures are high or low and also being out in the middle of nowhere?
Okay, multiple parts of the question. The first is, again, we have two technologies. Yes, we want one that can be mixed with cement. So that similar technique companies are using today for cement can be used when it's mixed with the cement, with the material. It just makes the cement impermeable and the gas can't go through it. So that's the case. So this is the exact same, whatever the companies today are implementing for using cement. For repair behind the casing, this case is the standalone material. It could be used by multiple methods. Some of them is what we call as dumb baler, which is the gravity based. The material is temperature controlled, and basically the material temperature is exactly the temperature downhole the minute it touches downhole, because the wells are all full with water. So the minute the material touches down, that's the temperature of the material. We engineer our materials based on the temperature, so the operators will have about 2.5 hours of ability to squeeze the material behind the casing. Usually that happens through having perforations in the casing and applying pressure above the material. That's water pressure. This is very low pressures, very similar to what the companies now do in what they know as cement squeeze. But we are the material to use when they cannot squeeze anymore. Because when they fail to squeeze, sometimes you cannot squeeze anything behind the casing because the gaps are too tight. That's the time we actually can use our standalone material. And we have success rates very high in that case because you can squeeze anything and we can actually go in the micro cracks, fill it, and stop the methane emission. Temperature control is critical. So not the same. We have different formulations of our material. Some can be applied when it's minus 40. And some actually can be applied when it's 40 C or 120, and we actually did this in East Texas. So you have to control the material. Temperature is a big issue.
Thank you so much.
You're welcome.
Hi, excellent presentation.
Thank you.
My name's Stacy. I've been a mentor at the Rainforest and taught entrepreneurial studies at UNM Anderson School of Management. My question was about, I noticed you've brought or hired 15 employees on your team. What's your forecast for how many additional jobs you might be bringing to New Mexico? I'm sure for all of us, that's part of our economic development, so we're excited about your opportunities you're creating for all of us. So,
thank you. The forecast, of course, is a function of two things. One, growing our revenue. We have planned to have a revenue of $3 million this year. And so achieving that goal, and of course, was the fundraising for the $6 million raising. We expect to be having a total between the US and Canada of 70 people to support $3 million development, annually. At the moment, that of course is not happening because of the limited revenue. But that's the plan, is to have a total of 70. Hopefully this is happening sometime in 2026. Here.
This is from online, but Dr. Taha, what is your business financial model? How are you making money? And is there any post-sealing maintenance and such?
So the financial model is the biggest part of it is to actually coming from operators. So operators need by law in many states and in Canada and worldwide to actually seal against methane emission. Not only by a regulation, but from a safety point of view for them. Sometimes that happens actually while the wells are operating, still operating. So the biggest part of our financial model is revenue we receive by working with operators worldwide. One also related item to answer the question also you have is that we actually are talking to some of the very large oil and gas companies. I'm not going to say the name of the company, but that's a very large international one. They are developing a robotic system to actually go through the whole well and bunch the well and seal and continue. And they don't have the material. And we actually are negotiating with them to be our material, to be the material of choice. So that is another part of the revenue. We also have signed agreements with cement companies to actually be the one providing this additive to them. And that will guarantee us an annual revenue. All of this is just happening. So none of it is finalized yet, but that is all of this are revenue. And the last one, of course, part of the revenue is the carbon credits that we can generate once we identify wells that need to be orphaned wells that we actually can seal and generate carbon credits. TS-Nano have an agreement to share 50% of the carbon credits in this case.
Thank you. One more question from online. Is your company being impacted by the federal administration shift in policies?
Yes. But what is the size of impact? We don't know. We have grants, and of course, as any startup company, having grants now, you're scratching your head, what are you going to do if they don't continue? But also there are impacts because we are an international company, and of course, not having the best relationship between the US and other countries doesn't help. But we are very hopeful that technology is a good ambassador, and we have very strong relationship with all our partners, so hopefully none of this will impact us. Yes.
I'm coming. Good morning. Thank you for the presentation. I had kind of a technical question, first of all, just concerning the methane emission. Did you find from the 70 different wells that were being monitored if it was like a consistent rate of emission or if it was variable over time? Generally speaking?
We call that it's a great question. We call that the wells burb. So they do not emit all the time. So that is why measurements of emission need to be happening over a period of time. So usually it's somewhere between 24 to 48 hours, continuous measurements. And it has to also, it could be repeated. For example, if we are in a very cold day, need to be done at a warm day. So measurements have to accommodate for the atmospheric conditions, but the wells do not emit consistently, average all the time. They have fluctuation with temperature and other fluctuation because of gas movements underground.
Really interesting. Thank you. Then I was curious, after oh, 1 second. I'm sorry. Let me gather my thoughts. I get a little.
Good morning, Mahmoud. It's Sue Prilazny. Nice to see you in person. My question is, if you're going to be hiring, you estimate 70 people, who will you be working with to train them for these jobs?
Of course, we have now a trained crew, and trained employees at TS-Nano. One important thing I didn't explain when I showed the 15 people. TS-Nano today, of course, the two academics in it is me and John, who founded, but we have large number. Actually, our COO is 30 years in the oil and gas industry. He's used to be a vice president for Halliburton. We have other engineers that worked for years in the oil and gas industry. So we have a very well-trained crew at the moment that's going to train many of the new employees. The challenge truly is finding the talent, finding the employees. I have to say is in New Mexico, the challenge wasn't finding engineers or finding people to work in the labs. This is available. The challenge was finding people in the field because many of the people working in the oil and gas would be referred to be living in Texas rather than New Mexico because of tax reasons and other reasons and training reasons. So that's been a challenge, finding people that can work in the field. But training, of course, we will do the training, and we use also other training agencies.
Okay, you had mentioned the disadvantages of other seals being made with cement and they crack. I'm curious, could you touch on the self-healing ability of your nanotechnology? Thank you. Sorry, I needed to gather that.
If I understand the question correctly, you are asking about the self-healing. So the material as we have it today does not have self-healing capabilities. But the material we are developing in our lab today, we got a $1.2 million grant from DOE, started in late 2024. We are developing now, and we actually have good success. And we have a consultant from UNM, Dr. Nick Carroll. We actually are developing a material that have self-healing. And our objective is to actually mix this material with cement. So whether it's a standalone sealant or if it's used with cement, it will enable self-healing. And the interesting part of the self-healing we're trying to do is we're trying to do a self-healing based on gas exposure. So once the material actually get that gas exposure, so if a crack happens, if there is no gas, don't worry about it, yeah? But if any hydrocarbon gas exposed in these cracks, the material will self-heal and close. That is the new technology. We just filed in with Reinforced last year, the start of this. So.
Very good talk, Mahmoud. One of my thoughts in understanding the business is there may be a possibility to offshoot the monitoring and diagnosis of wells that could feed into what you're doing, because I understand you do both. And it may be a niche to do the monitoring to then inform whoever's responsible that you have a serious problem. Because there's times, like for Navajo Nation, there's a lot of abandoned wells, but it would be up to some of the tribal authorities or the government itself to examine those wells more systematically rather than as they find something that they may or may not test. So it's more of a overall approach for the beginning diagnostics. And it seems like you do both at this point, the diagnostics and then the cure.
Yes, and the reason, thank you, Sandra, great question, and it allows me to explain an important point in our business model is because if you can do the diagnostics first, yeah, and let's say we have 30, 40 wells we are monitoring. Monitoring usually is not very expensive, but people need to pay for it. And then sealing, if you found 2 or 3, 4 wells that are emitting very high, you need to seal them, yeah? The objective we have is we actually could bring, if we found in 20, 30 wells, some wells that are emitting high, the owners do not need to fund, because many of the owners of the wells today in the native lands, in public, do not have the money. Yes, this is all the abandoned wells no one is supporting. You are waiting for the state to bring the money. But if we manage to find some wells that are emitting, we are connected to private capital that actually only wanted to invest in carbon emission issues. We will fund the whole process by this private capital. The owners wouldn't pay anything, and it's going to generate carbon credits to the private capital and to us. So it's a win-win. The owner actually have now wells that are sealed and abandoned, and we actually got money to do the job. That's why we it was a key issue for us to understand the monitoring. And the other thing is the relationship between the monitoring and the cure, because not all the wells, as I explained, made the same way. And the best way to cure is to actually understand more how things is happening in the well. And these data are, a lot of people talk about it, but they are unavailable. So we see a very big value of these data, especially if we develop, as we are working now, to develop AI systems to tell us, once we get the data, what is the cure, what is the solution, where is the problem along the well, and many other answers. Okay, thank you.
Well, thank you, Nora, for your great opening, and Dr. Taha for a really great, not only really a conversation. It's so great to see so many good questions coming from the audience. Thank you. So now we'll have a networking break, and then we will start our first panel session after that, so at 10 o'clock. Thank you. We are pleased today to have as our first panel, which is Energy and Water. Our moderator is Sandra Begay from Sandia National Laboratories. She's a distinguished member of the technical staff, and she is an expert in this arena, so we look forward to hearing from her and her panel members. In addition, I'd like to thank our friendly sharks, to investors Mike Freeman from Innosphere and Alejandro Munoz Mendieta from No Border Ventures. Thank you very much for being here.
Well, again, good morning. And those of you who know of my work, I've focused mostly the last 22 years working with tribes across the United States with renewable energy projects, and I'm also known for creating an internship program where I've had about 50 Native American STEM students that have been a part of our nation's leadership for tribes and renewable energy development, particularly in this United States. So I've been excited about those two accomplishments at Sandia National Labs, and I'm very grateful that Sandia is one of the sponsors today. We're going to have a panel focused on energy and water, and part of that is to be able to allow us in 45 minutes to have two of our guests give an overview of their work, and then I'd like to take a few moments to ask them questions after they present, and then we'll turn it over to the friendly sharks. Feng Chu is a scientist, a P-4 thermal plasma physics at Los Alamos National Laboratory, PLX, plasma jet-driven magneto inertial fusion. It reminds me of the X-Men. And we also have Ansel Blumenthal, R&D SNME mechanical engineer at the National Solar Test Facility at Sandia National Laboratories. It's great to have our two guests to give us, what type of work they're working on in the topic of energy and water. And we'll start with Feng Chu. You want to come up to the podium, and we have slides for him.
All right, thanks for the introduction, Sandra. Good morning. So the plasma liner experiment, aka PLX, at Los Alamos National Laboratory, is at the cutting edge of fusion energy research, addressing one of the world's most pressing challenges, the need for clean and limitless energy. I'm Feng Chu, the PI for the plasma liner experiment project. Did you know that the prospect of clean, safe, and reliable fusion energy has gone from a scientific fiction fantasy to something that can be achievable in the next 10 to 15 years. So far, over $7 billion has been invested in companies working to make it a reality. So, and PLX wants to do the same. So our hybrid concept offers a safer, lower cost, and a more scalable alternative to traditional fusion energy approaches. In addition, the PLX's innovative design eliminates reliance on costly magnets and lasers, so enabling like economical and repetitive operation and more efficient energy management. So beyond fusion, PLX can also support testing and verification applications such as spacecraft reentry, plasma energy storage, and advanced battery durability testing. So that being said, in the long term, we will focus on fusion energy generation. But in the short term, the unique capabilities of PLX can leverage us to support testing and verification for various fusion applications. And the plasma liner and target generated on PLX can also help reduce supply chain challenges. So here's a cool picture of our experimental setup at Los Alamos. It has a 3-meter diameter vacuum chamber with 36 supersonic plasma guns uniformly installed on the surface of the sphere. So our technology is a hybrid concept between magnetic and inertial confinement. So a few key advantages for our technology. So it's a non-destructive operation because everything happens in the middle of the chamber. So it separates the fusion burn region from the hardware, such as these plasma guns used to generate supersonic plasma jets. It's also a low cost because it doesn't rely on, so these hardware doesn't rely on like expensive magnets or lasers used for like magnetic fusion or ICF. And also it allows, so these advantages allow us economical and repetitive operation and easier management of the particles and energy generated from the fusion burn region. Fusion is a time-evolving and competitive area. So with multiple approaches vying for success, so there's always a room for multiple breakthroughs in different niches. So over the next 2 years, our key milestones include investigating plasma liner and target formation under different conditions. We're also going to perform integrated experiments with a goal of achieving compressed temperature over 100 eV or higher. We also want to expand the industry partnerships for testing and verification. And ultimately, we want to spin out PLX into a commercial venture. Hopefully this will happen this year, later this year. So fusion is within reach, and PLX can has a potential to be a game changer. By continuing to explore the short-term applications while advancing our long-term vision, we can accelerate the progress towards a clean, safe, and a sustainable fusion future. Thank you for your time.
Next, I'd like to invite Ansel Blumenthal to come and give us an overview of what he does at the National Solar Test Facility. Thank you.
Good morning, everyone. My name is Ansel Blumenthal, and I am excited to talk today about some of the research that is being done at the National Solar Thermal Test Facility, the NSTTF, at Sandia National Laboratories. The focuses in today's talk will be on agrivoltaics and food processing through thermal energy storage. So these are two distinct technologies. I'm just being selfish and talking more about what we have going on. So with how much I want us to cover in a short amount of time, I just want to touch on my background briefly. I am a R&D mechanical engineer with my graduate research being done in microgrid technology at the University of New Mexico, where I utilize both renewable energies and fossil fuels as fuel sources. Currently, I work at the NSTTF with my research in concentrated solar power, CSP, photovoltaics, PV, as well as thermal energy storage, TES. Slide. So here's a picture of our facility, the NSTTF. The large structure that you see here is the power tower, our solar tower, which is surrounded by heliostats or mirrors that are reflecting the sun's rays to a focal point on the tower to create extremely high temperatures. This can be used for many different capabilities, and we do a lot of partnerships frequently with local industry. And we can touch more on this after the talk. You can meet me in the atrium. I can tell you a little bit more about our facility. But for now, I just want to focus on a PV project and a thermal energy storage project that we are currently researching. So with the trending increase in solar gain throughout the Southwest, we are seeing increased levels of sun scorch and blossom drop in our cultivated plants, which is causing a direct negative impact to the New Mexico crop yields. This is affecting everything from green chili to tomatoes to blackberries to chard, everything under the too hot New Mexico sun. Our team has developed solar panel arrays on a cabling system that we're calling gained PV as a shading solution to minimize sun scorch and blossom drop, as well as lower evaporation levels. The uniqueness about our system is the ability to automatically raise and lower these PV arrays. So when cultivators need to pass underneath the fields, the solar panels can simply be raised for the machines to pass underneath, and after cultivation, the panels can be lowered back down to increase shading, maximize water conservation, and minimize effects from the wind. The bottom photo here is our 8 kilowatt system that we're deploying out at the Rio Grande Community Farm. So if you happen to be in the area, it's a beautiful walk. Go check it out. This system is going to have an integrated islandable microgrid with it that's going to be running the pumps for water irrigation, as well as ancillary power needs, and the ability to charge an EV tractor that we have. Sorry. There we are. So the initial positive data that we're finding from a deployed 4 kilowatt agrivoltaic system that we initially deployed at Sandia showed the minimization of evaporation through the agrivoltaic system is looking very promising and is opening up new avenues for innovation in ganked PV technology, specifically aquavoltaics. So using the same ganked PV system over acequias, arroyos, canals, any man-made waterway, we can supply a convenient power source as well as minimize those evaporation levels. There are many instances of this application in New Mexico, but I do want to mention the Central Arizona project to just quantify the impact or the potential impact of this technology. The CAP, the Central Arizona Project, is one of the main water canals for water being used in the city of Phoenix. This waterway loses 5.2 billion gallons of water each year due to evaporation. And along this canal, there are substations, pumping stations that push the water up to higher elevations. So through our aquavoltaic system, we could greatly impact not only the conservation of water along this 330-mile exposed canal, but also supply the power necessary to pump the water up to higher elevations. The progress in agrivoltaics has been through an NMSBA as well as a technological readiness initiative and a current technology commercialization fund that is ending at the end of this fiscal year. Through this grant, we are also doing TEA with the Jemez Mountain Electrical Co-op to understand how to integrate these systems in a scaled way into the rural farmlands of New Mexico. We want to expand to additional grants and partners to increase the TRL from an expected level 7 at the end of this FY to achieve an 8 or a 9. We are also currently looking into support from industry and community partners for the aquavoltaics initiative. Now, keeping with the food theme and our other project, a large research area at the NSTTF is in thermal energy storage, or TES, which is harnessing heat for long durations of time for thermal processes. In our case today, food processing, specifically coffee roasting. Coffee roasting conventionally uses propane or natural gas to roast coffee beans, typically with a rotating drum roaster that you can see in the photos here. This heating method can create conductive heating that impacts the quality of the beans, causing what's called tipping or scorching, more or less burning and non-uniform heating of the beans. Additionally, the efficiency of this method is incredibly low. The preheating and roasting process is very energy intensive, using large amounts of natural gas to, which we see as an unnecessary cost to the roaster. So our solution is to use a TES system supplied by renewable energy. Thermal storage has its advantages over chemical battery storage in that there's not a life cycle associated with TES like there is with chemical batteries. Also, the duration of energy storage is much longer. The maximum chemical battery storage caps around 4 to 5 hours, whereas TES has been proven to last many times that, potentially days. Another advantage, TES is cheap. It requires no rare earth metals. You can use materials such as sand, rocks, salts, These are the mediums that can store heat, which are easily accessible. Here is one of our TES systems that we have deployed at the NSTTF. This uses PV panel array that you can see in the bottom photograph, and resistive heating to heat the medium inside the container. Then we use fans to blow the air through the TES unit with the exhaust temperatures reaching the required 500 degrees Fahrenheit needed to roast coffee beans. The overall potential for heat can exceed up to 2,500 degrees Fahrenheit. This hot air is blown through the roaster, creating a convective environment to complete the roasting process. Now, with over 20 local coffee roasters here in Albuquerque alone and 3,000 roasters nationwide, there is a large market potential for development of a renewable energy-driven TES system for coffee roasting. There's also a potential for new flavor profiles as the gas fumes currently being exposed to the beans are no longer going to be part of the process. An initial NMSBA was done with Michael Thomas Coffee Roasters to begin the TEA for a new development of a coffee roaster for this application to maximize convection and minimize conduction, and therefore minimizing that scorching and tipping that we're seeing with the current roasting design. There's still TEA that needs to be done to quantify the overall cost savings that we would see over X number of years with the application of renewable energies over fossil fuels. But with the price of PV and the price of TES being so low, we see this is looking very promising. So for both these projects, we have non-provisional patents, one for each. Further research is still needed to optimize the roaster and develop a corresponding modular TES system designed for different roasters' needs, different production levels. Although the focus today has been on coffee, I did title the presentation Food Processing through TES, as I wanted us to leave with the knowledge that this application of TES can be used for industrial thermal food processing needs for barley and corn, wheat, pasteurization, you name it. The possibilities are extremely high. The market potential is immense, and this is just one example I've brought you to you today. Again, if you are interested in learning more or partnerships, we do have a booth outside in the sunroom, so feel free to come and talk. Thank you so much.
Well, thank you both. I think this microphone is on. Right? Thank you. There we go. I have a few questions before we turn it over to the friendly sharks. For each of you, if you could take your time answering. One of the interesting things about where we are right now is times are changing, right? So when you think about advancing the technologies and the research that you're doing, and let's say you're at a startup level outside of Sandia, what would be your talent needs? You heard from TS-Nano about the number of jobs they're creating in which sectors. Do you give us an insight into that talent that you anticipate in a short period of time should this begin as a startup on its own?
Do you want to go first? So since so building this, the picture I just showed you, it took different generations of scientists and postdocs, building that over almost more than 10 years. So as a physicist myself, and I definitely think that we will need lots of engineers to build the next generation of PLX if we spin it out. So, but fortunately we have University of New Mexico. We actually work with a professor there. There are like 10 people, I think, in our group. They used to be his graduate students, and now they work at Llano as scientists. So we have a pipeline for the talents in New Mexico, and also we have 2 national labs, and both of the labs have fusion research. So we have lots of physicists, engineers. So I think that's gonna be a good place for building a fusion reactor here. So.
Is this one on as well? Great. I think that we all are aware of the potential for the Southwest gaining more innovation in PV and subsequently through that thermal energy storage. Both of these projects that I talked about today, I think, have not just good market potential, but the ability to expand to hire people outside of our engineering groups. I think that technologists to be able to deploy large megawatts of PV into rural farmland is very achievable. And I think that the technology is already there. We're just taking another baby step to progress it a little bit further. And because this capability is something that I think is cheap, it's easy to produce, it's easy to deploy. There's a lot of potential for hiring a lot of New Mexicans to, increase our crop yields and increase our reliance on renewable energy.
And this question is for both of you. What funding do you need? You've got a broad audience here with a lot of researchers, institutions, commercial businesses, venture capitalists. So keep your mind open broadly of who you're talking with. What type of funding do you need over the next year, and for what purpose?
So our research has been supported by ARPA-E in the past 10 years. So we received about I think $12 million in the last 10 years. But fusion energy research definitely costs lots of money, especially and also because all the hardware right now is at Llano, and we want to move everything out. That will also cost money. I think so. Yeah, we will. There are lots of for example, we're working with Simon Woodruff in Santa Fe, and there are a few fusion companies I'm aware in New Mexico, and we definitely welcome other venture capitals, who are interested in fusion research to invest on us. So as I mentioned, the immediate purpose of the funding would be moving the hardware outside Llano and trying to find a new home for our experiment.
I think you said it well with the idea of keeping our minds open to ideas from venture capitalists, from people in the community. As an engineer, I can have blinders on where I get focused on the technology in an engineering way, and having the ability to have a community come with ideas to expand in ways that I wouldn't think of, I think is how these technologies can progress. So, having these open avenues of communication, I think is paramount for these type of projects. And we're always looking for funding through the NSTTF. We're always writing grants to progress this technology. And for us, a little goes a long way.
with these type of projects, PV panels are fairly cheap. Food processing, thermal energy storage, as I touched on in the slide deck, is cheap. So getting ideas from the community, I think, is an integral part to the progression of this technology.
Great, thank you. And I will turn this over to the friendly sharks.
Sure. So first of all, thank you so much for sharing your great work. A couple of questions, one for Feng and one for Ansel. Feng, if you could tell us a little bit about, if you have a patent and what the patent is on. Is it on the design? Is it on the process? If you could share a little bit of information on that. And thinking about your business model, are you thinking of licensing, this, or do you want to create full-scale, hardware in different places and sell that? And for Ansel, if you could tell us a little bit about, for the first project, which crops do you think this is most, that it makes the most economical sense? Like which crops are hurt the most because of the scorch and the different problems you outlined?
Yeah, thanks for the question. So, yeah, we're working on filing the first patent. So we spent the last 3 years working on the liner formation on PLX. So, yeah, we're working on one that is about the liner formation. And so since we got the funding from ARPA-E for another 2 years, and we'll be focusing on investigating the target formation. So that will be another patent we're gonna file, hopefully in a year, once we get some experimental results. So, and then, as I mentioned before, people have been working on building the hardware and the control system, and we also wrote our own program to control the experiment. So that also has been done over the last 10 years. So that can also be potentially become the intellectual property for this experiment. Sorry, what's the next question?
Just on
the business model, right? Yeah. So we're working with Simon Woodruff to estimating the cost for building a reactor-size fusion reactor, and also I guess because we won't the fusion won't probably happen anytime probably over 10 years or something. So we also want to focus on the short-term applications for testing and verification, as I mentioned in my presentation, because we have the very cool hardware, which is not accessible anywhere else, so which provides us unique capability of doing those tests. So, yeah.
Thank you.
I mean, we are a green chili state, and I think that in my mind, more than anything, is one of the main focuses that we are after. My initial understanding before getting into this project was that the hotter it is, the hotter the green chilies are going to be, and that is true up to a point later in the season. Once the green chilies have already germinated, propagated, grown, as we're seeing temperatures rise earlier and earlier in the year, we're seeing this adverse effect happening with these blossom drops and sun scorches that are diminishing the yields of our most favorite crop. And so that is our main focus. And that is going to be one of the plants that we are planting out at the Rio Grande Community Farm this season. So again, I implore you to come take a look at the system at different stages of the season. And it's an easy walk. It's a beautiful walk. And we'd love to have you out there.
Thank you.
So Feng, maybe I'll just start with a question for you. So just coincidentally, this past summer, we did a project on fusion looking at VC and private equity trends, talent and federal funding. And we're really kind of looking at Colorado, New Mexico as what does that industry maybe start looking like in the future, and what's the supply chain around it? So just a little bit of context on why we did this. The conclusion of the analysis, I would say, is that if you're not in Seattle, the Bay Area, or Boston, you're going to have a very difficult time bringing a fusion technology to market, mainly because the private capital is still highly concentrated in these areas. And that's a friendly question, by the way. It's how do you see transitioning from the federal funding you have, RPE, DOE, to the market, and how you started the process of connecting with the very specialized funders in this space. Just kind of where are you in that realm?
Yeah, that's a good question. So yeah, I definitely agree with you. So actually, I went to an RPE Fusion Summit last year in Seattle. They mentioned that they have like 6 fusion companies just in Seattle area, which is I think the city with the most fusion companies in this country. And definitely in the Bay Area, we know there's a Pacific Fusion and other fusion companies. Yeah, that's a good question. So in a way, like New Mexico doesn't have any kind of sort of fusion companies right now, or maybe some companies focusing on the application, but there's no like a fusion reactor or test bed or something. But I think we do have lots of advantages compared to them. For example, so in the last year when we were talking about where we're gonna find a new home for PLX, some people mentioned maybe the Bay Area, but the renting of like a warehouse or something is very expensive over there, and our experiment is like, it's huge. It's like 10 feet high or something. So we definitely we need like a pretty big high bay, and also we need overhead crane. So things will be way cheaper here. And also it's just, for example, if there's a place in Santa Fe, we can just move it out there directly from Llano. It's pretty low cost. Yeah, and also, as I mentioned before, we have 2 national labs and a bunch of universities, and we all have fusion projects there, so it's, we have the advantage for access to the talents in New Mexico. So.
Okay, and Ansel's somewhat of a similar question. Just having worked with a whole bunch of ag tech companies over the last couple of decades, one of the biggest issues we see constantly is even when there's demonstrated high ROI for the operator, there's all kinds of practical barriers to adoption. And so more thinking about the agrivoltaics application, and just curious how do you see incentive structures playing into adoption of the technology? Because again, a friendly question is I'm not skeptical about it, but just seeing what appear to be high ROI technologies applications for farming and ranching that just don't get adopted at scale. I'm just kind of curious about that.
I think that's a great question, because the farmers that we interviewed through this process to see how to deploy this technology, they're set in their ways. They have a certain way that they've been doing things for years and years, decades and decades, and the idea of bringing changes in, there's pushback. But I think that what we were finding when interviewing, these folks was that keeping things as simple as possible has a higher likelihood of being deployed. So with our system showing both the advantages, because there is now this shift of, I am having a lower crop yield. I am seeing the effects of, the sun scorch. How do we mitigate that without disrupting my typical process, we made the system as convenient as possible. So we have these automatic actuators that the farmers don't have to do anything but switch or hit a switch, and the panels will raise to the desired height. There's no manual labor that goes into it. There's no winch system. It's very basic. It's very straightforward. It's very cheap and easy to mass produce. And I think that those things are going to hopefully create an environment that allows our technology to integrate with something that's been done for thousands and thousands of years, and something that we as New Mexicans know is necessary for our culture. And that's really the hope, is that keeping things as simple as possible will allow us to integrate our systems into a wide variety of the bucolic areas of New Mexico.
Well, maybe for Feng, just because definitely not a technical expert whatsoever in fusion, but just kind of curious, how much capital do you think you can accumulate from DOE and other granting agencies before you get to early commercialization? Because it seems like that's a pretty key gap you're facing, is a TRL level that's going to make sense for a private investor at some point to come in. And how far off are you from that? And not making any commentary on what's happening in Washington necessarily, except what's your view of where DOE is going in fusion just overall, and are you in the right place at the right time for DOE funding?
Yeah, that's a good question. So we just received about it's a little over $1 million just beginning of this year for us to be able to continue this project for another 2 years. But I think the ARPA-E's view is basically they want to for example, just trying to get you started, to building the test bed and try to test the concept. So in the past, they have supported many other projects, for example the Rialta fusion in Madison. It's a mirror machine. So they got the supports from ARPA-E, and then they basically do the testing and verification, and they know the fusion concept is going to work, and then they spin it out. So that's going to be the same thing for us. So we're still working on testing our new approach, which is kind of unique because this is the only fusion concept in the US right now. So once we, so the two key parts for this new fusion concept is we have a plasma liner, which is a plasma shell. They provide pressure or inertia to compress the target in the center. So we spent the last 3 years studying the liner formation, and then we're going to focus on the target. So once we're after that, hopefully in a year, we will know, this concept, really works, and that's the time we'll start to scale it up and build the next generation of PLX. We also Lino has some support for us as well to move the hardware outside the laboratory. And so that's why we also were looking for private investment, basically to hire engineers and physicists building the next generation PLX.
I think one for Ansel real quick, and a little bit along the lines of developing relationships with different cities or stakeholders. We know that the city of Phoenix is very innovative and very forward-looking. If you could tell us a little bit about how you've gone through that process of building that relationship and where you are in terms of them thinking about adopting your...
Yeah, so that was just kind of a quantifiable example of the impact that this technology could show. But I think for our stage in the technology, especially with aquavoltaics, where we're just kind of, fleshing out the idea, we still want to be focused in New Mexico. So, we have the same problems that Arizona has, that we're, very susceptible to heavy evaporation. And I think that just seeing those numbers, seeing, that unit go to a B, in front of, seeing that billion, and just knowing that that's water loss that I don't think that the Southwest can afford, and finding solutions to mitigate that is where our focus is. And but again, I think that this is a problem for the whole Southwest, but our focus currently with where the technology is in its development is New Mexico.
Thank you.
I would say that we're a little bit out of time, but we could squeeze in one question. Somebody who has a burning question for our panelists, I'd appreciate that. Do I see anyone? We can get a mic to you. Raise your hand high. Here we go.
As you walk, I will also be available in the sunroom afterward if anybody wants to talk further.
Hi, I'm Eve Fain, and my great uncle was the state water engineer of the state of New Mexico for many years. We've been in the water business a long time. I'm looking for someone to partner with me to remove plastic from the water. I listened to you. I think it's great. It sounds wonderful. My concern is how much plastic is the device shedding? I mean, preventing evaporation, that's a no-brainer. And we have no control where water goes or doesn't go and how much falls out of the sky. So do you have any answers for me on that?
Yeah, absolutely. So our system, I think that and it goes back to your question, Mike, as well as the simplicity of our system. We're using two beams, in essence, that don't penetrate very far into the ground because the tension on the cabling doesn't have to be that high to create the span-sag ratio that is necessary to keep these panels up. So in essence, the materials that we're using are metal for the posts, cabling system to hold the PV panels, and additional cabling system below that to mitigate the to maximize the damping, and which allows our system to sustain up to 90-mile-an-hour winds, and then the PV panels themselves, which are the conventional PV, which is mostly made out of glass. And so there's very minimal plastic involved with our system. And I think that's a very good concern. And, I'd love to talk to you more as well today.
Thank you. Thank our panelists. We appreciate that. And now you have time for a 15-minute break, and then we'll have the next panel at 11 o'clock sharp.
I'd like to introduce our next panel, which is Biosciences and Agriculture. And Devin Fell is our moderator. He is the Vice President of Engineering at Centaur Medical Systems, and he will introduce his panel. Thank you.
Hey, folks. Just wanted to give a little bit of personal background for kind of how I got to New Mexico before I introduce the panel. Medical startups for, kind of since my Mechie and biomed background, decided to go overseas, travel the world, work for Schlumberger for a couple years, and then really got into medical devices around 2009, joined a Carnegie Mellon spinoff that was a surgical robotics company. And we had a successful exit in 2016 for $275 million. After that, I joined a brain-computer interface company competing with Neuralink. They're called Paradromics. So they actually brought me out to the Bay Area, and I spent 7 years there, and joined Centuri Medical Systems about 4 years ago. And so that kind of brings me up to New Mexico, right? We had a company in the Bay Area, very expensive burn rate, and I found out about the NMEDD program. So that's New Mexico Lab Embedded Entrepreneur. So basically, that program hooks you up with a researcher at Los Alamos, gives you funding, gives you resources. And so as part of that, we moved our company from the Bay Area to Santa Fe. We set up our lab space at the Santa Fe Business Incubator. And since then, have really turned the corner on a really hard technical problem that the lab has helped us solve. And so since that, I've been here exactly 1 year ago today and have really loved it. Kind of wanted to plug some of the programs that I've been involved in and learned about since I've been here as a young entrepreneur in New Mexico. So I mentioned the LEAP. We also have NMSBA, as well as EDD. I think I saw Michael Prosnitz here. EDD recently gave us some money. We use that directly for some regulatory consultants who cut about 2 years off our timeline to market. So these programs have direct impact on your company. And if anybody wants to talk more about that, I'm happy to talk about that because I'm still learning as I've only been here a year. So with that, I'd like to introduce the Biosciences and Agricultural panel. We have Weston and Christina. I'm going to let you guys introduce yourselves. You're going to do a much better job than I will. So thank you.
Okay, disappeared. We're trying to figure out how to switch the slides. Yeah. The large one? Okay. How do I get that back? There we go. Okay. Good, thank you. All right. Hi, everybody. I'd like to thank the Rainforest Innovations for inviting me to talk today. My name is Christina Salas, and I'm an associate professor at the University of New Mexico. I'm actually a new addition to the School of Engineering. I have a primary appointment in the Department of Mechanical Engineering with a joint appointment in the Department of Chemical and Biological Engineering. I worked for the last 17 years in the UNM School of Medicine in the Department of Orthopedics and Rehabilitation, where I actually started. I was a student at UNM. I completed my PhD in biomedical engineering, and I have bachelor's and master's degrees in mechanical engineering. And much of my research up until now has been on the development of medical technology, specifically to address problems and limitations that exist in our healthcare system here in New Mexico. As well as a variety of other things that are not applicable to this right now. But I'm going to talk today about, I'm here on behalf of Peak Performance Prosthetics, that's what we've called our group, and I'm introducing a technology that we're calling the Dynamic Prosthetic Interface for socket support during cycling. All right, so this technology was actually developed with the support of a mechanical engineering senior design team. You can see the 5 students that we had supporting the team there. Myself, as well as an orthotist and prosthetist at the UNM Carrie Tingley Children's Hospital by the name of Evan Long, as well as Natalia McIver, who's a senior research scientist at the UNM Department of Orthopedics. The 3 of us mentored the senior design team in the development of this technology. Unfortunately, as things go, all of our students graduated and moved on, and so our research and development team now includes the 3 of us, as well as we've added a graduate student in mechanical engineering who is actually doing this research as part of his master's thesis work. We've recruited an orthopedic surgeon, Dr. Selena Silva, and we're working very, very closely with Kyle Stepp, who is a New Mexico-based U.S. Paralympic athlete, and I'll talk a little bit more in a moment about his contributions to this work. The work that we're doing right now is currently funded with support from UNM Rainforest Innovations, their GAP funding, or the seed funding, I'm sorry. This is $25,000 of funding, and I'll talk a little bit about the work that we've been doing on this technology with that money. All right, so we know that movement is medicine and that people who are physically active are at much lower risk of death due to a variety of ailments, including cardiovascular disease, diabetes, obesity, including suicide, compared to inactive individuals. And unfortunately, there are millions of Americans that are living with limb loss and limb difference who are unable to afford prosthetic care specifically for physical activity. And some of the reasons for this, a primary reason for this, is inadequate insurance coverage. All insurance coverage really is just required to basically cover a single prosthetic device, and that's generally your primary use device that you have for walking, right? And coverage for anything more than the primary device is generally deemed not medically necessary. And because of this, there generally are high out-of-pocket costs for anybody interested in getting a secondary device for any purpose whatsoever. And unfortunately, even when they can afford these out-of-pocket costs, there are very few commercially available options that exist because most of these devices are actually custom-made per each person. So in November of 2023, Evan introduced me to Kyle Stepp, who is, as I mentioned, a U.S. Paralympic athlete, triathlete, that's based here in New Mexico. He is also the strategic partnership lead for an organization called So Everybody Can Move. The So Everybody Can Move organization they do a lot of things, but one of the things that they've been most successful at is providing model legislation that can be adopted by states across the U.S. in order to supply financial coverage for prosthetic and orthotic care at a level equivalent to federal Medicaid, as well as their focus being prosthetic and orthotic care, specifically for physical activity for people of all ages. And so some of the successes that they've had so far from 2022 to 2024, they were successful at helping enact legislation in 8 states, including the state of New Mexico. And in 2025, they have legislation that's already been introduced in 9 states so far. And here's kind of a little map of what that looks like. All of the orange areas are those states in which legislation has been enacted to support this. Most of all the solid purple is where the legislation has already been introduced. The ones with the purple dots, they're kind of in the works right now, and then everything in yellow are the targeted next states that they're aiming for. So we have a number of goals in partnership with Kyle as well as with So Everybody Can Move. And we're starting with our first goal. That's what I'm going to introduce today. And that's to enable accessibility to sports cycling for transfemoral amputees. It's interesting that even Paralympic level cyclists, they require custom attachments for their bicycles in order to be able to perform their sport. Unfortunately, this is very costly. It requires prosthetist intervention at all stages. It's rigidly fixed to the frame via a carbon fiber bonding system. The bottom 2 left pictures actually show what Kyle's bike looks like when he's preparing for a race. This is rigidly fixed to the frame, as I mentioned. It has no adjustability after mounting. It's not transferable from one system to another, so it becomes very expensive. As I mentioned, intervention is necessary, and any revisions or any minor adjustments require starting entirely over again. And again, all of these things require prosthetist intervention up until now. And so there's some photos right there of some world Paralympic athletes with their transfemoral prosthesis and the different types of mounting systems that they've had a custom addition to their bike via their local prosthetist. All right, so our technology is the dynamic prosthetic interface, which is focused right now on enabling cycling accessibility for transfemoral amputees, but we do have plans in the works for a transtibial option that's actually undergoing right now. We are working on right now. This offers a universal mounting option for any bicycle frame. These include stationary bikes, exercise bikes, and so forth. There's no prosthetist or specialty provider intervention that's necessary for the use of this. We can easily attach it or detach it from any bicycle frame system. We have implemented 4 degrees of adjustability so that even when it's put on there, the rider can make any adjustments as they need to a number of angles. And of course, we have been working with Kyle, so we've optimized this for the elite Paralympic athlete, but we are actually hoping to implement some of the modifications from our research in order to make this available to the everyday user. That's ultimately who our target audience is. So with the Rainforest seed funding that we've had so far, it has supported active work in a single subject cycling study to assess the quantitative improvements that in cycling biomechanics that our system can provide over the existing fixed frame systems. We have IRB approval for that. We are using some advanced biomechanics software in order to look at a variety of different joint angles that have been proven as measures for us to be able to assess biomechanical capability and efficiency in a cyclist. As I mentioned before, our outcomes, we're primarily looking them to inform our structural modifications and our mounting modifications for the system. Most importantly, we're looking at cost savings and weight minimization for, as I mentioned before, obviously we want to make this available to as many people as possible. And so our current system is made out of grade 5 titanium, and while that does provide the strength targets that we're hoping to, or that we are aiming to achieve, unfortunately it's also very high in costs for both materials as well as manufacturing, and it tends to be quite heavy for someone like Kyle who's interested in using this in his races. So our goal is to develop a system that's made out of powder-coated aluminum. Obviously, we can reduce our material costs, our weight, and so forth. It will reduce strength, but we believe that with the combination of that and the carbon fiber mounting system, that we will still be able to achieve all of our goals that we have set for this system. Talk a little bit about market size and growth potential. So there are approximately 1.7 million people in the U.S. that use a prosthetic limb. There are about 185,000 amputations done annually, and about 65% of these are to the lower extremities. Approximately 58% of these folks are under the age of 65 at the time of amputation. And I mention these because these are more likely the folks that would be interested in the use of this technology, although not exclusively. So looking at the lower limb prosthetic market, currently I have both U.S. as well as global numbers on here. Globally, there's a little over $1.1 billion with a compound annual growth rate of 4.7% spent on lower limb prosthetics at the moment. So potential customer segments, we are aiming to start with transfemoral and transtibial amputee athletes globally. Just within the U.S., we're talking about 15 to 20,000 people, and this is not just the elite athlete. This is any athlete that's interested in this, in need of this technology. We then are looking towards transfemoral transtibial amputees in the U.S. states that are currently eligible for this additional prosthetic coverage, as I mentioned before, and then of course, a much larger target is transfemoral tibial amputees globally. All right, so what are some of our needs? So I'm an engineer, I'm a researcher, I like being in the lab and developing technologies. I'm not great at pitching to my technologies, and so we're looking for partners with business acumen and most specifically a shared vision to create equitable and life-changing access to prosthetics. So we are aiming right now to bring in about $150,000 for continued R&D for the transtibial options, as I mentioned, as well as increasing the mounting variability options, and for production of the optimized technology. This has been reduced to practice, but it's currently in use only by Kyle at the moment for him to assess use of the technology in a race, and so it's been working very well for him, and so we'd like to expand production of this so we can start getting it out to more people to use this. We're also looking for partners for NIH STTR grant writing efforts. We're interested in a multi-center clinical trial of cycling athletes with transfemoral amputations, so looking for partners who are interested in working with us on that. And then, of course, mentoring, legal, financial, any overlooked regulatory considerations that we have not looked into thus far. Thank you.
guess I don't need this. Thank you. Beautiful. Hello, everyone. Good afternoon. My name is Wes Medlock, and I am CEO and founder of Path to Plate. Throughout my entire career, I've devoted my life to improving and changing food systems, and from food systems coordinator to director of a food hub to developing statewide land access programs and president of local food co-ops, I have a personal and professional mission to finally support our local farmers and ranchers and give them finally a fighting chance to become viable and profitable. So from the early days of my career, I understood right away that farmers and ranchers are just simply cut from a different cloth. They're the hardest working people that we all know, and every single day they wake up to do the hardest job on earth, and that's to feed us. And as someone who has started a farm from the ground up, I can relate with those struggles. And my job with Path to Plate and its mission is to provide market opportunities for our local farmers and ranchers. And the markets that local farmers and ranchers currently have traditionally are farmers markets, CSA programs, and with a future like that, we can expect for the next generation of producers to rise up and put food on our plates. And New Mexico faces a very similar challenge that a lot of other states do, and that's they export the majority of the food that they produce, and they import the majority of the food consumed by that state. And for New Mexico, it exports over 90% of all food produced in the state, while it imports 95% of all food consumed by New Mexicans. And a lot of these disparities can be attributed to 4 problems. The first one being fragmented supply chains. So currently, a farmer or rancher, if they want to access an institutional, a wholesale, or a retail market, they have to go through an extensive process and basically end up trying to figure out who has what, who needs what, for how much, when do you need it, where does it need to go, and it creates a fragmented supply chain. Secondly is the high cost and wasted time. If you're a local producer or if you're an institutional wholesale or retail buyer, you spend an incredible amount of time making phone calls, back and forth emails, going through spreadsheets, trying to figure out who has what. The third problem is a limited market access. The reason why a lot of our small and medium scale producers sell at farmers markets and through CSA programs is because they don't have access to efficiently sell to larger, more profitable markets. And fourthly, unpredictable supply and demand. Every year there's an imbalance and discrepancy between what the buyers have or what the producers have and what the buyers need. And there's no planning process, and currently to date there's not a platform or a software that allows for local producers and these buyers to be able to negotiate and transact future procurement orders. The solution is actually incredibly simple. It's to create the ability in the software and the marketplace to allow both of these parties, both the producer and the buyer, to seamlessly connect and essentially create a marketplace that allows producers and buyers to know who has/wants how much of what, where, when, and for how much, in all in real time. Supply to demand creates a marketplace to where the producer can directly access the buyer and not have to go through costly intermediaries and middlemen to secure those transactions. A distribution network is integrated into Path to Plate using existing distributors with a very unique distribution ticketing system that allows real-time distribution orders and notifications across a statewide network. Thirdly is a forward agreement marketplace, which allows both the producer and the buyer to negotiate and transact fulfillment orders for a future point in time all the way into the next growing season, which allows the producer to optimize their crop production schedule and allows the buyer to plan in advance so they can plan their menus accordingly. And fourthly, streamline procurement. The procurement processes from a school district to a hospital to a senior center are going to be very different. The food safety regulations, different. The distribution, different. Pat to Plate allows the solution for all of that to be streamlined in-house so the producer can focus on producing and the buyer can focus on buying. So who is Pat to Plate for? I'm saying producers and I'm saying buyers a lot, but to break it down, and for those of you in the back that may not be able to read this, I'll read it out real quick. So when I say producers, I mean producers of all sizes, small, medium, and large scale. Farmers, ranchers, and food entrepreneurs. And for buyers, institutional, wholesale, and retail buyers, that includes school districts, hospitals, restaurants, food banks, senior centers, food hubs, daycares, grocery stores, and catering businesses. Come on, there we go. So looking at the market opportunity for Pat to Plate, in 2024, Pat to Plate had a $304 billion market for U.S. food e-commerce markets. And with a compound annual growth rate of over 16%, it's projected to reach $1.19 trillion by 2033. Looking down at the lower left side of the screen, there's been a 30% increase in farm-to-table restaurants and the demand for local food to be in more restaurants. $4.1 billion was spent in 2020 from farm to institutional sales, and the total number of schools that participated in, schools that participated in purchasing directly from a farmer was over 70,000 schools in the school year of 2022 and 2023. And the total addressable market for Pat to Plate in the U.S. is $1.36 billion. The business model for Pat to Plate is quite simple. It's a flexible, straightforward, subscription-based model. The three different user types are producer, buyer, and distributor. For a producer, it is $29 a month or $325 a year. For a buyer, it is $49 a month or $560 a year, and for distributors, $90 a month and $1,080 a year. The traction since Pat to Plate was conceived has been truly humbling and incredible. Back in October, just a few months ago, we had a request from the governor's office to meet about Pat to Plate, and they were thrilled with the idea and said that they want every producer and every buyer in the state participating in these types of transactions to be using Pat to Plate, and bringing on the Secretary of Agriculture with New Mexico and several other different state agencies. Secondly is New Mexico Department of Ag, who's been a tremendous supporter and collaborator with food safety, with logistics, and targeting specific producer types and buyer types to begin testing. The New Mexico Grown Program is actually an initiative from the governor's office to help with food safety and streamline the connections between the local producers and the buyers. And this makes up about 7 different state agencies, including Public Education Department, New Mexico Health, Aging and Long-Term Services Department, Early Childhood, so on and so forth. And lastly, over the past 18 months, I've spent an incredible amount of time meeting with producers and buyers all across the state, from school district food procurement specialists to 5-acre local farmers to farmers that have over 100 acres, trying to figure out what needs to be met and what's not currently being met, and then that goes directly into the development and has gone into the development of Pat to Plate. So the next steps for Pat to Plate is to launch next month. We have been working tirelessly for the past 2 years to get this properly done, and going through a very extensive, like I said, a very extensive round of interviews and meetings and surveys, trying to figure out what's not working. And currently, right now, we are testing with a group of producers and buyers, and we are planning to launch next month. Secondly, in the first year, reaching 120,000 cells from roughly about 150 subscribers in New Mexico. Thirdly is marketing campaign with our various stakeholder agencies. And fourthly, recruiting our core team development, or our core team trying to recruit and develop the different skill sets and backgrounds and individuals that we need to ensure this succeeds and is able to commercialize to other states. And that's it, everyone.
How about this? All right, I guess we'll just do questions here. So I guess for both of you, I'm curious what your kind of barriers to entry are. Christina, as you know, are kind of curious, are you a medical device or more consumer product? Is the FDA in your way to get to market? And Weston, as you have some revenue already, what are more barriers to scaling for you?
Check 1, 2. Hey, there it goes. Do you want to go first?
Yeah, sure. I'm sorry, just to make sure I heard you correctly, you asked if this was more of a commercial product for like direct to consumer, and is that what you asked?
Yeah. So I'm first of all curious: is it a medical device? Is the FDA going to be a regulatory body in your way? And if not, are there any other barriers to entry to get into market, or can you, once you've developed your device, can you basically just sell to the customer right away?
Yeah, I think from what I've learned so far, I think it depends on how we sell it. So so what I showed you up there is basically just the attachment that allows it to adapt to any existing prosthetic socket. And so if we were to go that route, then there would be some prosthetist intervention because we would need to have a mating piece attached to a socket. My understanding is that if we sold just the system that I showed you up here, there would be far fewer considerations with regard to regulatory considerations that we needed to take into consideration prior to actually making it available to customers. If we were to sell it as an entire socket system, which would then prevent the need to have that prosthetist intervention, then I think there are additional considerations we need to take with regard to the socket interface, additional testing that would need to be done for the interface with the patient. I mean.
Okay. And Weston, now that you have some revenue, so I'm curious more about your barriers to scaling your product.
Yes, just to be clear, we have not launched yet. Okay. So revenue pending, but revenue expected.
My apologies.
No, all good, all good. So barriers to scaling. So Pat the Plate intends to commercialize to other states and other states specifically for a number of reasons. Number one, a lot of states have very unique food safety certifications and landscapes that need to be tailor fitted to that specific state. Secondly, we want to really highlight the opportunities to provide more local, fresh, high quality food to the masses, and keeping food systems and food sheds local to a specific state is very important for ensuring that. And thirdly, each state knows its producers and its buyers best. So commercializing to other states on a state-specific expansion model is the path for Pat the Plate. And I would say that the barriers for that immediately are just honestly staffing, being able to create capacity to be able to reach the potential that Pat the Plate has. That's my number one thing. I could use 10 of me, 20 of me right now. That'd be fantastic. And so yeah, increasing our capacity through staffing, as well as identifying the most streamlined path forward to each state's food safety specifications and requirements is very, very important. Path to Plate is patent pending, and we are using this as a vehicle to be able to set the stage to expand into other states.
All right. So you guys talked a little bit, Christina, you talked a little bit about your funding pathway. I think you mentioned STTR, excuse me. And Weston, I'm curious about your funding pathway. Would you be going non-dilutive? Would you be going for private, seed, angel? What's your plan there?
Yeah, thank you. So currently Path to Plate is funded through a USDA grant called the Specialty Crop Block Grant. And I think we all sort of understand the current atmosphere and landscape of federal grants right now. And I am pursuing capital outside of grant funding to ensure that things like what we're experiencing now aren't the bottleneck for expansion. So pursuing outside funding and then utilizing and harnessing grants for expansion projects that are very specific, but going beyond that, yes, looking for venture capital. Yeah.
Great. And Christina, if you want to expand on that at all as well.
Yeah, sure. So the reason I said that we were looking for partners with this is, as many of you know, with SBIR, STTR funding, we need to separate the business from the research team. And one of the limitations that I frequently have with technology development at UNM is that, especially this type of more of an orthopedic type medical technology, is that I'm one of the very few researchers at UNM that is working on this technology and has laboratory resources that are available for us to continue to do the research and development of this work. And so because of that, it's hard for me to also then take that additional role on the business side. And so, and I don't even I don't have a background for that either. So, I know what I don't know. And so I want to ensure that we have the right partners for something like this so that we can continue to pursue the funding that may, hopefully, will be available to us.
Well, that kind of leads into my last question before we turn it over to the shark, or loan shark here. But, was just curious about, you kind of hinted at that already. What are some unique challenges you face to being in New Mexico to your company? And it sounds like resources are one. And if there's anything else you want to expand on, please do.
Yeah, I'd be happy to answer that. So we are at an advantage that we are the only university in the state with a medical school that is associated, that is on our campus, and so having access to consultants and additional folks that we work with, especially our orthopedic surgeons, our prosthetists, our orthotists, our folks that work in physical therapy and so forth, has been a huge advantage in the development of all the technologies that we've worked on, and not just the one that I'm presenting today. So that is a huge advantage, but that unfortunately is about it. We don't have a large number of investors that are focused on medical device development. For many other industries, having the national labs adjacent to us is an advantage, and there's not a lot of medical research being done specifically at the national labs that are near us. Although we do work with facilities like the Center for Integrated Nanotechnologies up at Los Alamos for some of the materials research that we do. Unfortunately, a lot of the other work that we're doing, we can't leverage those adjacent resources, and so I'd say that is one of our biggest limitations, is that when we do want to make these connections, we generally have to go outside of the New Mexico borders in order to do so.
Same question?
Yeah.
I would say, so the first thing that comes to my mind is marketing. Statistically, New Mexico is the #1 hardest state in the nation for marketing. And a challenge that I think a lot of entrepreneurs have in New Mexico is how to effectively market. their product or invention in New Mexico, and due to the lack of broadband connectivity and the language barriers across the Hispanic population, Native American population, all of the different rural communities, that's what makes it the hardest state to market. And I think that really trying to crack the code on how to have a game plan and more of a straightforward path of how to market specific industries that account for the complexities and the nuanced challenges of New Mexico and its diversity of its population, which is fantastic, but it makes it challenging sometimes to figure out how do you tap into a proper, effective marketing strategy in the hardest state to market something.
Wonderful. Thank you, guys. And pass it over to our loan shark, please.
Yeah, I guess I got all the meat for myself, right? So thank you for that. That was great. Question for you, Christina, and I know that your project and what you're building is for peak performance, but wondering if you've given any thought to maybe a lower cost solution. And this is me going to, potential commercial paths for you, partnering up with folks like the Pelotons, maybe, those beach bodies, gyms, et cetera, which I know that for some of those hardwares, they can fall under HSAs, FSAs, et cetera. So wondering if you've given that any consideration.
Yeah, absolutely. So as I mentioned, we are targeting a much less expensive, with regard to both material and manufacturing costs, option for this system. And that's because, as a researcher, I feel like I always aim for developing a technology that is very low cost. If it were up to me, if I was a pharmaceutical researcher, I'd be the one focusing on those orphan drugs. And it might not have the biggest impact, but if I'm helping somebody, that's really what I want to focus on. So me as somebody, I don't have a business mind, unfortunately, and so sometimes that conflicts with folks. I'm aiming to develop something really inexpensive so that I can sell it for a low cost, so that everyone can have it, if it's to make it accessible for as many people as possible. But I do understand, if depending on who we're selling it to, or who our customers are, that is something that can be changed. But yes, absolutely. So we're focusing on getting it as low cost as possible so that we can create the biggest margin possible for whomever is interested in purchasing it. And hopefully, if we can make it accessible for those who are uninsured or underinsured at this point, that would be, of most interest to me. But, I know that's not the way everybody thinks.
Super, thank you. And for Weston, maybe, first of all, congrats on the platform, very much needed. Wonder if you could tell me a little bit more about, as you onboard, whether it's buyers or sellers, if you have any sort of diligence process or scoring system that's more about keeping the quality and the integrity of the folks that you have in that network.
Yes. Could you actually reframe that, or
Sure.
Repeat that question?
So maybe a way to reframe is, how do you keep the network as high quality as possible in terms of who's on there?
Yes. So the networks like I said, my entire life has been devoted to local food systems and working with state agencies and these farmers and producers and these buyers, and ongoing conversations. It's a very, very fluid network of communication with all these different user types. And as far as the rollout, how we maintain the integrity of the site and ensure that it is fulfilling its maximum potential to get local food to the plates. We have, yes, a whole plan of how to follow up with those individuals. We have planned workshops virtually for producers and buyers to have feedback sessions, as well as communicate all the different features and aspects of Path to Plate. With a 10-minute presentation, I couldn't go into all the different bells and whistles of Path to Plate. But yes, it's paramount that it's not just push the big green launch button and then hands off. if the component of the humanistic side of it is forgotten, then it simply won't work. Because when you're talking about food, it's very, very personal, right? We all, raise your hand if you've ever eaten food, right? And so ensuring that the network is accounting for the different perspectives and ensuring that it's meeting their specific need, that's, yes, we do have a plan for that.
Thank you. Open up to.
Yeah, open it up to the crowd. I don't know if the microphone, how we're going to do that. Yeah.
Could you talk about institutional barriers that you deal with, like conflicts of interest?
Conflicts of interest? Maybe I can answer the first part of that, and it'll answer the second. So for me, my number one priority is food safety, right? It's critical that Path to Plate have the highest standards possible to ensuring food safety. And so I think that when looking at institutional buyers, New Mexico is actually very special with its local food in regarding food safety, and that is it has an approved supplier program, which is a program administered by New Mexico Farmers Marketing Association, and that's a food safety certification recognized by the state of New Mexico that allows local farmers and ranchers to be able to sell specifically to school districts, senior centers, daycares, and food banks. So that element is definitely went into all of Path to Plate's design, and it's integrated on the back end. And then secondly, I would say procurement. Every hospital has their fancy procurement system. Every school district has their fancy procurement system. And so trying to align all those different procurement processes so that it accounts for those and can streamline it, that's been, I'd say, one of the day one challenges that we've navigated.
So I may have misspoke, or you may have misheard me. What I said was institutional barriers. You're both involved working in universities trying to build businesses. And so universities have programs to help faculty and staff build businesses, but there are also some barriers, and I was wondering the types of barriers or challenges that you face working within a university and building commercial activities.
Yes, I'm sorry, my brain went to buyers instead of barriers, so I apologize. Yes, I can't, I can only speak for myself, but yes, you are very correct in that it's not a very straightforward, clear, ABC type process. And so I've worked with the Arrowhead Center. I'm an employee for New Mexico State University, senior program manager. And so I've worked with the Arrowhead Center to secure a patent. And the intent, the goal, the plan is to enter into a commercial license agreement as quickly as possible, and we're definitely on track to achieving that so that I can access different opportunities and resources and funding that would otherwise be prohibitive as a university program. And like I was saying before, I don't think it's sustainable or responsible to create something like Path to Plate and then just depend on the next grant, the next grant. So trying to look at this, and I do look at this as a very viable business, and to me that's the quickest way to commercialize and expand.
I feel like I'm airing dirty laundry. Hopefully, I think what I'm going to say, I should begin by saying there have been significant improvements. But in my experience, especially as a faculty member within the Health Science Center, there used to be a lot more limitations with regard to faculty who were interested in developing technologies, but then also being tied in some way to any business that would stem from that technology development. And as I mentioned, I worked for 17 years in that campus, and so it was frustrating for many years. I mean, I teach a class called Biodesign, and the whole entire focus of that class is to develop technologies and then hopefully move them towards commercialization. And so with those barriers, whether real or imagined, but they sure felt real to me and to a number of my colleagues. It basically made me feel like I had a little opportunity to maintain a role in the technology that I was working on, and that kind of made me sometimes feel like I didn't want to necessarily spend the time to continue developing technologies if I was going to have to just let them go or release them, or hopefully have somebody license them or something like that, and not be tied to the company or to the technology itself any further. Rainforest Innovations I've been working with them for many years, and they've been extremely supportive with regard to helping us obtain the provisional patents and moving through the patenting process, and that's been really great. And with their support, as well as with some transitioning, our main campus tends to be a lot more open to allowing faculty members to maintain roles, as you heard Mahmoud Taha earlier today, to be a researcher, a faculty member on campus, and to also maintain a stake in a company that that has technology, or that's built off technology that was developed at UNM. So.
I think we're over time, but it looks like maybe one more question, or I don't know.
This one will be quick. Thank you. Jeremy Hammer from Leadnet Impact. Weston, could you just clarify quickly? You had your licensing an issued patent from NMSU, or it's still pending? And then, based off of that, I'll ask the quick follow-up.
Yes, provisional patent.
Okay, it's a provisional patent. And what do you see when it gets converted to a non-provisional, and then your ideal claim set that you would have? How does that stack up against the competitive field?
I'm sorry, I didn't hear the first part of that.
Oh, so when the provisional when you convert it to a non-provisional, and you get your ideal claim set, which nobody knows what that will be, but given what you think it will be, how does that stack up compared to the competitive competition and their intellectual property?
Yes, so very, very soon, I don't want to speak for a person in the back, but in the next couple of weeks, basically I'll sign a development license, which licenses the patent back to a separate company, a Delaware C Corp. And then after the development license, once there is capital that is brought to the business, then it will immediately trigger a commercial license, which has a much more latitude for the business operation and where the revenues go. And I want the revenues to be going to Path to Plate, so I can reinvest those funds back into Path to Plate. And yes, compared to the competition, I can't speak to contracts, and I can't disclose all the terms and conditions of those contracts, but the commercial license is very friendly to the business being started and what revenues can be captured and funneled to that business. So it remains a very competitive business model.
Oh, okay. Sorry to clarify. As far as I was more pointing to the competitive field and what claims you would, be obtaining, and how that would distinguish your company from the competition.
Yes. So a few different aspects. Number one is the forward agreement marketplace. That is extremely novel and unique. We've done tremendous amount of market analysis and research among competitors, and it simply does not exist. The second one would be that the patent includes is a distribution ticketing system, which leverages existing networks and existing distributors to be able to move local products from point A to point B. And then thirdly, the self-serve food safety verification, which allows producers to self-verify their food safety credentials so the buyers can have confidence in ensuring that they're purchasing safe products. Yes, does that answer your question?
Yes, thank you very much. Appreciate it.
Awesome.
Thank you all very much.
Thank you for a very great discussion. So we have a 15-minute networking break, and I would ask you to grab your lunch and sit right back down because we have a noontime panel. Thank you. So our lunch panel is about venture capital in New Mexico, and I'll be your moderator for this panel. And we have 3 great panel members who are investors. We have Katie Rice, who's the managing partner in Tramway Venture Partners. Next, Mike Freeman, who's with Innosphere, and he's also with the NSF, Colorado, Wyoming Climate Resilience Engine, and he's a general partner in Innosphere Funds. And then we have our third panel member is Adam Hammer, who's co-founder and CEO of Roadrunner Venture Studios. So welcome to our panel. Thank you all. Okay, so to start out, I want to ask a question about, tell us about the history of your firm here in New Mexico, kind of what your activities have been when you started, those kinds of questions.
Sure, thank you, Lisa. I'm Katie Rice. I'm a partner with Tramway Ventures. And Tramway and its partners has been a part of the ecosystem for a while now. The fund itself was started in 2020 by Juanita Tuttle, who I think many of you know. She is, in many ways, a founder of our New Mexico ecosystem as far as investing and startups are concerned. So Fund 1 was in 2020. Fund 2, I'm sorry, in 2017. And then Fund 2 we raised in 2020, and we started raising Fund 3 in 23. And we focus on early stage, so primarily seed and A investments in med tech, biotech, and health tech. So I'll start with that because I think we're talking in more detail soon. Oh, all right, go ahead, Adam.
Maybe I'll go next on this one since we're New Mexico based. Hi, everybody. Adam Hammer, good to see you all and happy to be here today. Thanks, Lisa, for the invitation. I'm from Roadrunner Venture Studios. We actually started, Lisa, the same year that was my first attendance to your Innovate New Mexico event in 2023. We had Norman Winarski, who's one of our deep friends at Roadrunner and Frontier Fund, who's former CEO of Stanford Research Institute, that was actually your keynote speaker that year. So Roadrunner was funded in 2023. We had our official launch in December of 2023, where we opened up our headquarter facilities in downtown Albuquerque, and we opened up our studio that year. We are currently incubating about 5 companies, and we have launched our Roadrunner Fund last year with an anchor investment from the State Investment Council in kind of mid-2024. So we've been on the ground here for about a year and a half. We are a venture studio and venture fund, and I'm sure we'll talk more around what the distinction between those two are, but happy to hear with you guys.
Hey everybody, my name is Mike Freeman. So we're a little bit different in terms of the venture capital arm of Innosphere is not geographically centered, except we happen to be in Colorado and look at companies from the Mountain West and Midwest states predominantly. So a little bit different mandate there. And I'll try to maybe, Lisa, maybe comment on things, questions I'd say maybe that might have a unique New Mexico focus. I'll let my colleagues here maybe speak to that, and then speak maybe to some broader themes, kind of around the region, let's say. We've been in venture capital since 2017. The reason we got into VC, we're a science and technology incubator, nonprofit, and we're working with lots and lots of companies and could not figure out why the investment community at that point in Colorado was not frankly backing tech companies. And so we got into venture, frankly, by necessity. Fund 1 was 2017, Fund 2, 2023. And then Innosphere has also launched 2 funds in Israel, so we have a view into a very, very different marketplace that I think helps us be better investors locally. That's our VC history.
So if each of you could talk about what your business model is and of sorts, what kinds of investments do you want to invest in, have invested in, the stage of investment, and maybe also the target sector?
Sure. So at Tramway, we invest in the sectors broadly are med tech, biotech, and health tech. And I'm repeating myself a bit, but I'll go a little deeper. We primarily start with Series Seed or Series A investments. And we go pretty early. We certainly look at companies pre-revenue. Primarily we're looking for great entrepreneurs. To date, all of our investments have been in New Mexico, but we can invest within the region. I think that's an important for our portfolio and our ecosystem is to strengthen and continue strengthening our relationships with our broader southwestern region, and we're looking to lead from New Mexico. As right now we're the only health bio focused VC fund in New Mexico, and one of the only in kind of the surrounding region. So it gives us an opportunity to lead from New Mexico and create a portfolio within the region. But yeah, we're primarily looking for great technologies and, more than anything, great entrepreneurs.
So at Innosphere, we're crazily 27 years old as a nonprofit incubator, and over many, many years, the technology die was cast for us, frankly, based on the place we've been in, which is Colorado early on and now the region. And so no surprise if you look at the region, if you will. Energy, kind of clean tech, climate as a bucket is a critical area with the labs, multiple states. Life sciences, we don't do pharma, so we do virtually everything else in life sciences, mainly just because of the time frame. Small fund, you might, we can ask that question later, why that doesn't work. And then we're pretty active in, I'd say, complex software. In our industry in VC, you might call it vertical SaaS. That just might mean software SaaS that's very specific to maybe energy or health or fintech. And so if you look at our portfolio, we have some pretty interesting kind of deep domain expertise in vertical SaaS.
So we're maybe a hybrid of the 2 other examples here on the stage at Roadrunner. So if we take a step back and think about why we were founded and what's our thesis, we believe that the United States has 3 superpowers when we think about American competitiveness and security across the world. The first is we have some of the deepest capital markets. We have the deepest capital markets, in the world. We have some of the best talent in the world, and we have some of the best research institutions in the world. Our belief at Roadrunner is those 3 elements don't necessarily work together to build new companies. And what we hope to do is be a platform that connects those 3: founders, research institutions, and capital markets. So we are a venture studio first, which means that we sometimes co-found companies out of places like Sandia or UNM or Princeton University or UC Santa Barbara. Practically, that means spinning out disruptive science and mapping it to operators, giving it capital, building the business model around it. It could also mean working with founders in residence. So we have folks that are on our team who have either had a past exit or are promising founders that we bring in to build companies alongside us. They might have an idea when they come in the studio, or they might spend 3, 4, 5, 6 months with our team looking at the things that we are analyzing in the labs, at corporate studios, and in other settings that we could build together. And the third is that we invest in companies. So we also have a fund that is working with the studio to invest in companies that we find promising. All of our attention is devoted to frontier technology. So that would be, for us, that's advanced manufacturing, that's advanced energy and climate, and it's advanced compute. So that's quantum, microelectronics, sensors, all those fit within our mandate to build companies that we think have generational impact here in New Mexico and elsewhere, and also serve the purpose of keeping the country secure and competitive.
Thank you. I'd like to turn to a question about your view on the strengths and weaknesses of working and investing in New Mexico.
Sure. So I have a longer list of strengths and weaknesses because I'm an optimist and I love living and working here in New Mexico. I like to say, I'm not from here, but I like to say I got here as quickly as I could. I came here as an immigrant from Poland as a child. And so I'm in a big way living the American dream. And I think New Mexico is a place where you can build your American dream. It's in a way, like a microcosm of what that could be. So I think we're all really lucky to be here, and I think we have a lot of strengths. And especially when we look at VC and startups and that world, I certainly would pick tech as our number one strength. I mean, we have just a ton of technology, as we know, with the labs and the university. And I had my principal made some notes for me. When you look at ecosystems around the country, we're number one as far as R&D as a percentage of the GDP. And we're really high up there as far as a percentage of the workforce working in either science, engineering, or with a health doctorate. So we have a lot of tech, and we have a lot of high-tech people, right? People with really high-end tech backgrounds. And that's a huge, huge strength, I think. I think our ecosystem is a strength. I think it's been, we've been building it. Lisa and I have been part of this for quite some time. Before I became a partner with Tramway, I was with Epic Ventures for about 15 years, and I founded a company and raised a few $1 million of VC right here in New Mexico. I'm also the founder of the Ski Lift Pitch, and that, along with many, many other organizations, including this today, we've got a thriving, active, growing ecosystem, and I think it's really important and a big strength here. And then I do think we have more access than ever, or I would say entrepreneurs have more access than ever to early stage capital, very early, so pre-seed and seed, which is a strength. And I would say at Tramway we're seeing really great deal flow with better companies than ever, more sophisticated business models and plans in general. So we have a lot going for us. I would say the weaknesses are access to later stage capital, which that's part of the reason I'm here with Fund 3. We're trying to raise a much bigger fund, bigger for New Mexico, so that we can stay with our deals we can stay with the later stage rounds and bring in bigger investors for the later stage rounds. And then the second weakness I'd mentioned is the management talent, which I think is improving. But I think, if you look at what we have here, we have more of the tech talent. And what we need is more people who have built and exited companies to be part of our immediate ecosystem. And I think we're all working on that, and it's improving. But I'd point to that as a little weaker than the strengths. So. Sorry, go ahead.
Doesn't matter. It doesn't matter. So we're here in New Mexico because we believe in the potential of the state. So I moved here. We founded a company here. We founded a fund here. It has national reach, but it's headquartered here because we are extremely bullish on what New Mexico has to offer. 3 strengths that we talk about all the time in our team. One is, as Katie alluded to, we have some of the highest R&D talent per capita in the country. There are some amazing institutions here, UNM, Sandia represented, I'm sure there are others, that have amazing science, amazing scientists, and a lot of potential to convert that into products and into companies. That's a huge strength. Not every ecosystem has that. Two, we have a phenomenally supportive state government and city government. So we have folks here from the EDD. They have been key partners in building companies alongside us at Roadrunner, and I'm sure for the others on the stage here. The EDD is unique here. It is not like in other places. They lean in, and they are trying to make companies here and keep them here. There's a real partner there. Two, you have an amazing asset in the State Investment Council, who has been one of our largest backers and has been really thoughtful about how to do what sovereign wealth funds need to do. Over the horizon investing that is patient and that is focused on building capabilities for a state, not over the next 1 to 2 years, but over the next decade. And there are folks here, Brian Adams included, and others who have partnered with the SIC, and I think we all can attest that it is a really, really important force, and it's a massive strength for this ecosystem. The third is there's just a legacy here of working with the government and innovation. There is, in the DNA of New Mexico, an innovative culture. We have done it. We have done it during the Cold War era. We did it in the 90s, and we'll do it again. So we love that there is this legacy here that we feel like we're helping continue and reinvest in. We have all the trappings to be a place where there will be several unicorns come out of New Mexico over the next few years. I wouldn't be here if we didn't believe that in our bones. It will happen, but it is because of state government, a lot of amazing research institutions, and I think also a legacy here of pushing the envelope. Here are the things that we could be better at. One, we have to learn to fail. When we look at founders, when I look at somebody coming to the door and ask for a pre-seed check, if you have failed and run a company and it all blew up, it's a good thing. You had to have done it before. You've had to have tried. It's a badge of honor. It's a badge of honor in Silicon Valley. It should be here. I don't know that it's always the case here. Two, we have to learn to work together. Events like what Lisa's putting together here help us do it. There's a lot that's been written and researched around the beauty of Silicon Valley. Silicon Valley is never going to be replicated. You're not going to have Silicon Valley here. But what you can have is an ecosystem that's focused on 2 or 3 or 4 critical industries where we can be a global leader in frontier tech. And we can talk about maybe what some of those might be. But we can replicate some of the magic here. But what it requires is a lot of soft tissue, a lot of connections and willingness to introduce to other folks and opening up your network. We have to do that here in New Mexico. It's what's made Silicon Valley amazing. It can be that way here, which means being open around how do I introduce somebody who maybe I'm not even funding to a customer, to another investor, because I want them to succeed. Their gain is not my loss. Their gain is also my gain. Those are 2 things I'm really focused on. And 3, I think continuing to build founder density, illustrating to more people that you too can build a business and you too can be a founder. And let's find more ways to get founders together to learn from each other. Yes, they can learn from funds. Yes, they can learn from advisors. But most importantly, founders and entrepreneurs learn from each other. That's things like Entrepreneurship Club. That's things like this event. That's things like what the New Mexico Angels and others are doing to bring founders together. We have to do more of that. We need more founder density. Humans learn by doing. Get founders working together. We don't do enough of it, and I wish we would.
And so I won't add to the strengths because I think you have local folks that know that way better than I do, frankly. So maybe I'll share a perspective on what's happening in the middle of the country in the mountain states, just as because I think every part of the middle of the country has this issue. So one of the things we do at Innosphere every year is do a really deep analysis of the Midwest and mountain states, where venture capital is originating, who it's funding, meaning companies, who the investor is, and what industry. And one of the things we've learned over the last, 5 or so years, which is, I think if you're in the investment world, you understand this, but without data, it's hard to come up and make a statement about this. But in the Midwest and mountain states, the vast majority of VC that's invested is imported. Now, on the one hand, that's great. You want private capital coming to your state. That is 100% an objective. New Mexico does far better, by the way, in local VC than most of the other states around it. In Colorado, we import about 93% of all VC. And so I want to connect a dot here on ecosystem challenge around venture and entrepreneurship. Until you get higher levels of local investment, backing companies, and those companies making money and exiting, I think it's impossible to grow a long-term ecosystem. Why? Because let's look at Colorado. Every time a company gets sold, which is mostly how companies exit, someone outside of Colorado makes money in a VC fund that pushes that to their limited partners or investors. And so if you look at an ecosystem that's taken decades to grow, that we've been part of, in some specific areas, this is a huge limiting factor, in my opinion, for how, not just Colorado, but frankly, all states will grow in terms of their tech ecosystems. Now, the other factor is you need a critical density of companies to be successful, then to exit, to create the talent pool. And so, as I look at New Mexico, New Mexico has about 30 to 35 companies exiting a year, which is that's really quite good for the level of VC investment. That's, I think, a big goal for all of us in the middle of the country is how can we really help our community get more companies moving, back them much more specifically to help them exit, meaning you can't help everybody. Sorry, I know that's not a great message at an event like this, but focus in on the companies that have the most potential. And then, once founders exit, local investors make money. That is a huge tailwind to growing your ecosystem. So I just want to kind of point out, I don't think that's a challenge unique to this state for sure. And I'd say, virtually every state we look at invest in, that's similar.
Thank you. Great comments. And yes, I think our ecosystem has grown tremendously, certainly since I've been here almost 22 years now, just by evidence by everybody in this room. I'll have one more question, and then if you want to be thinking about your own questions, we'll take some audience questions next. What are some of your thoughts about what we all could be doing to support our early stage startups?
So I think that's a great question. And I think a lot of what Mike and Adam have said actually is part of my answer to this. But I would mention two things. One, and I think I'm speaking to people who already do this, but if I think we all need to be cheerleaders for New Mexico. I think, when I talk about the fact that we have less management talent, for example, that's a real thing in venture capital. As we build these companies, we back founders more than technology. It's a combination, but we're looking for great founders. But as the company grows, they typically need some additional people with ideally those failures and or successes, like Adam said, even if their company didn't succeed. We need people who have built companies. And so, that's like a gap where we need those people to come to New Mexico. And I think everybody in this room knows that not everybody is dying to move to New Mexico. I was not one of, when I came out here, I like to say, I was like packing my bag as I was finalizing the interview because I knew I wanted to live here. I love the Rocky Mountains. I thought this was just my dream come true. But not everybody feels that way, so we all need to kind of get that message out there that it's a really, really wonderful place to live. I think a lot of people don't, when you mention to them, oh, would you come to New Mexico? It seems either they already know and they're excited, or it seems foreign. So opportunities for them to come here and experience what we all know is a part of that. And I think, when I founded Ski Lift Pitch, I had this in mind, like in addition to introducing entrepreneurs to investors they could never meet otherwise, or give them that first chance to make that meaningful connection. I wanted those investors to come here so that they would tell their friends and have a reason to come back and look at our companies and so on. And so we all need to, get the word out about how great it is to live here and give those individuals reasons to come out, for various events and various successes and different, different reasons to come out and see what we're doing. And the second thing I would say is along the lines of what Adam said about, I guess promoting entrepreneurship, right? Giving people an opportunity. But I would say my focus would be to give young people a chance to do that. I think, Silicon Valley, and I completely agree that we will never be Silicon Valley, and that's okay, because we're doing our own thing. That's amazing. But, one of the reasons Silicon Valley is what it is because of Stanford University. And of course, we have UNM, which is an amazing university as well. But what we need is for kind of that culture of entrepreneurship and awareness of what it all means at that lower kind of hungry, still building careers, still out there to prove myself stage. And I think there are things happening to promote that and improve that. So at Tramway, we launched an internship program last fall, which I'm really excited about because I've seen this work really well in other states, Utah most notably, where you have active VC intern programs where students have a chance to work on investments, source deals, and so on. And I think about my own path. I started VC relatively young in my career, and I think that was, looking back, it was like a gift. I mean, I was networking. I found the opportunity, but I did have this like really wonderful opportunity at a young age, and I would love to have more chances like that for young, smart college kids to have a chance to see what we do, so that even if they go off to wherever to build their careers, some of them will come back to New Mexico because they have connections here, and then we'll have this richer pool of really smart people who are knowledgeable about what we do and investments and startups. So, I'm sorry, Adam.
Sure.
We'll go in order.
What we can all do to support founders. A couple thoughts. So one, I really think New Mexico's hungry for a vision. I think that we can't have 8, 9, 10 focus areas. We have to have 2 or 3 that we, as a community, the folks in this room, believe are our comparative advantages. Look, over the next 10 years, it is going to be determined which frontier technologies dominate and where they are built. So there is a race happening right now globally, certainly US, China, that's well discussed, but also within the United States around which states are going to win in which new markets. Maryland is going head first towards quantum, right? Texas is thinking about space. Indiana's thinking about hypersonic missiles and rocket engines. What is New Mexico going to be the leader in? What are we going to look back and say, we marshaled all of our state resources and all of our efforts to focus on winning in 3 areas? I don't know what those 3 are. I have a view. I know others in this room do too. But we, as a community, have to collectively arrive on that and push for it. You can't have 9 focus areas. It doesn't work in business. It doesn't work in public policy. Let's go find the areas where we will dominate. And let's agree and all marshal our resources towards it. The second thing we can do to help founders, in my opinion, is we have to do more to seize momentum. We have momentum right now in New Mexico. Like, I don't know that folks feel it and believe it, but I travel the country. I go from state to state. We look at all these different places. There is something happening here. But it is only true if we believe it. I see David Perez nodding his head in the back. He just wrote an op-ed on this point. There is something happening here. But we have to believe it. We have to manifest it. And we have to carry that psyche into what we build. This can't be a place where we feel like we're losing or it's incomplete or we're going to be left behind. No, we have something happening here. There is something changing. There are a lot of trend lines that are pointing our direction. And we are about to be feeling the momentum, so we need to embody that and bring that to our founders. They should feel excited to build here, and we should be out there being the chief business officers of our state, finding more founders to build here, because I fundamentally believe it's one of the best places to build a deep tech company in America right now. But we don't make that case well, and we all should.
So Adam, I totally agree, and I'll say, because I spent most of my career, in terms of working with startups, investing Colorado-based, we have the same problem. We have 9 advanced industries. Are you kidding? No, I understand from the state's perspective. I'm not criticizing that, by the way. They have to be all things to all people at the Office of Economic Development. I totally get this. But I think we 100% suffer from this. My suspicion is that probably virtually every emerging ecosystem has the same challenge of identifying a couple things. I absolutely agree with that. I may go a slightly different direction because one of the questions Lisa asked, and I didn't actually answer because I forgot. We like to invest very early, 150,000 with an SBIR grant, or not even then. And so we're coming very, very early. We're backing technical founders. So there's almost never a business person on the technical team to invest in. So that's kind of the when we get involved. And we really like that because that's kind of our incubator nonprofit roots, is we're getting involved very early with technical teams. So I think, sorry, you didn't have that context. So therefore, I will say, I think in virtually every region in the middle of the country, because we run around to tech transfer offices and pitch events. So our N is probably 12 states-ish. I would say for technical founders, what's missing is more guidance early on in the research project, or sorry, in the research process, I should say. And this is really, really hard because why do you go research something? Because typically you're passionate about and interested. You may not start your research journey to imagine commercializing anything. That's perfectly okay. But most researchers we see when we kind of intersect with them, they're 15 degrees off of the commercial market or more. And that I really think is fixable the longer I have gotten into this work. And we're really struggling to try to figure that out. But research teams, in my opinion, need more business guidance and more corporate involvement much, much earlier. And that is easy to say and really hard to do. So that's kind of where my mind is right now is, I think we've reached back pretty far in the research process in the incubation program and investing. But here's a great example of not a university example, but a physician came to us and said, hey, I've been working in this specific surgical arena for a couple of decades. Here's a tool I need. I developed it. I paid for the IP. It's working to patent. Guess what the market is? About 25 million. And just didn't have that understanding as an inventor that fundamentally the product they were developing for themselves largely had zero market. Zero market meaning that no investor would ever write a check for it. That is an extremely common situation, unfortunately. And so I guess I would say to whatever extent you can do that in Mexico is really help the inventors early on get the market signals that are correct and help them tune the research. I think the commercialization output will be much higher if we kind of systematically can do this better, really as ecosystem builders, let's call it. So that's just kind of one thing that's really on my mind right now, and we're struggling with, sort of in the real world, I say how to do that.
Okay, great comments from our panel. Do we have a question from the audience? Arlene in the far back.
Hi, everybody. David Perez, the New Mexico Angels. Just wanted to add a little piece here. The Angels just completed a data survey of venture capital investing in the state. So I thought 2 data points might be helpful to this conversation. In 2019, there was $5 million of venture capital invested in 10 companies. As of mid last year, 2024, the total for those 5 years are $560 million in 140 companies. So there's the data to support the growth and illustrate how our ecosystem is growing. And as Adam said, this is a moment that we have. Now is the time where we have to move this conversation in our startup economy forward. So if anybody would like a copy of that venture capital report, please hit us at the New Mexico Angels. We'll be happy to share that out.
Thank you, David. That's really great news for our state.
Thank you. My name is Jessica Moose. I'm with Sandia National Labs. I had a question mainly for all of you, I guess, but Adam in particular. So you talked about creating a critical mass of founders and how that's really important. We're starting to build a critical mass of VCs here. What are you guys doing to work together to manage deal flow and build relationships amongst VCs?
It's a great question. I can answer it first. So there's a couple things that we're doing at Roadrunner, and I'm sure Mike and Katie have some things that they're doing as well. We are working on ways that we can coordinate some of the more national funds that have SIC backing to make sure that we are all marching to the same beat and making sure that we are staying coordinated around founders that are really exciting and things that they can be doing in the state to have presence. So we're unique in that we're a national fund that's based here. And we, thanks to the vision of John Clark and Chris Cassidy and Steve Moise and many others at the SIC, we're fortunate enough to have backing here and founded here. And so what we're trying to do is build a bit of a consortium of those national funds that follow Roadrunner into deals, pay attention to the founders that we're working with, but more broadly, not just at Roadrunner. We will play this role of hopefully being a connector. That's not isolated to me. It's also Brian Adams, who's here, and others that are trying to play that role. But we are really trying to make sure the full weight of the venture capital ecosystem, not all of whom are in New Mexico, are focused on founders, are focused on bringing companies here, and are focused on really developing and building a bench of talent here in the state. That's one of the biggest things we're trying to do. On the talent front, we're also trying to work with folks like Mary Monson, who's here at Sandia, around ways that we can bring scientists out of the labs who are curious, potentially taking entrepreneurial leave, to come experiment with the studio. What would it look like to build a company around my technology? Maybe I'm not sure I want to leave Sandia, but I want to spend a few months exploring that. Sandia is doing programs like that. You're there, of course, as well. And so we're trying to work with Los Alamos, UNM, Sandia on building more platforms to give talent the opportunity, when curious, to build companies and underwrite some of that risk so that they can go back. If they said, hey, I tried that thing, entrepreneurship's not for me, I want to go back to the lab, that's fine. But we have to do something. And at Roadrunner, we're trying to build those pathways with our partners as well.
Thanks, Adam. I'll go next. It's a great question, and you're totally right. We all have to work together as we grow. And yeah, here locally, Tramway, we do a lot to support UNM and CNM, which I mentioned ski lift pitch, which is just something I'm very passionate about, and it's a way, it brings a lot of investors from out of state to New Mexico and brings them together. And then we meet regularly, of course, with our fellow VCs here and with the labs. And then we're also trying to strengthen the relationships outside the state because, as much as we want more capital here, we need the co-investors to come from all over the country. And I think that they are more interested as what, that stat we just heard from David. I mean, it's really impressive, and we have more eyes looking, and we need them to stay interested and come look at the companies. So one of our venture partners at Tramway is based in Silicon Valley, and one of our initiatives internally we're working on is to bring more strategic investors to look at our companies. In a lot of cases, that makes sense to have a corporate or a strategic investor within the syndicate of traditional VCs. So we're working on those relationships, and we're also looking in the near future to spend a bit more time networking with the surrounding states, including Texas, Arizona, to show off our portfolios and our colleagues' portfolios here in New Mexico to bring co-investors here. And that many of our portfolios do have a co-investor from out of state, and that's important because as the rounds get bigger, you need syndicates with deeper pockets and also with different networks, right? We can't if we're all doing the same things with the same groups of people every time, our network won't grow, right? We need a combination of networks to come together in New Mexico. So those co-investors from out of state are really important. Oh, sorry.
Yeah, then maybe in Colorado, for our fund in particular, a little bit different focus. What we've found over the years is the first 2 million, 2.5 million-ish is pretty impossible to raise. And so we've really focused pretty exclusively on pre-seed seed, called small A. Small A round to us typically is a seed extension round. And so if we're doing a medical technology, for example, we're going to target 3 investments, usually in software 2. So if you imagine that first $2.5 million, we're squarely focused there because we find companies pretty handily can find the later stage funding without a lot of support from us, but that early stage capital is really the hard nut to crack, in the ecosystem we're working in.
Okay, we have time for maybe one more question from the audience. No questions? You answered everything. That's great. I want to thank our panel for really great discussion and comments, and thank you for all your work you're doing in building our ecosystem. We'll now have a 15-minute break, and then our next panel will start at 1 o'clock. Thank you. I'd like to introduce our moderator for our next panel, which is about aerospace and space. Okay, our moderator for this panel will be Chris Corbine. He is the Director of Student Entrepreneurship Programs at the Arrowhead Center at New Mexico State University. So welcome to the panel.
Hello, everyone. So a little bit about myself, briefly, why I'm moderating the aerospace panel. Recently, last few years, I retired from the U.S. Air Force, where I was a flight engineer on HH-60s doing combat search and rescue for a majority of my career. Ended up in this entrepreneur space where I work at Arrowhead Center. Arrowhead Center provides economic development throughout the state using, through entrepreneurship and workforce development programs. As the Director of Student Entrepreneurship, I oversee K through 12 entrepreneur programs, as well as collegiate level entrepreneur programs, an internship, and the NSF I-Corps program, which helps technology transfer out of the university and in conjunction with our IP office. So, but most importantly, we're here to discuss with David Mitchell, who is the Associate Professor of Electrical and Computer Engineering at New Mexico State University. Miko Estrada, who is the research engineer, at Cosmiac from the University of New Mexico. First up, David with his presentation.
Okay. Great. Okay. Well, good afternoon, everyone. Thank you for the introduction, Chris. So, is this clicker? Okay, great. I'll continue. So I'd first of all just like to start off by introducing our team related to this patented technology. So my name's David Mitchell. I'm the principal investigator of the National Science Foundation funded project Coding for 5G and Beyond, and where this initial discovery was made that led to our invention. I spent 5 years previously at the University of Notre Dame's Wireless Institute, where I worked with Dan Castell and Tom Fuji. They're pioneers in the areas of digital communications, error-correcting codes. Our PhD student, Homayun, he handled all the initial numerical simulations, extensive validation of our theory. He's now at Samsung as a lead engineer in error-correcting codes, which is one of our potential partners, and I'll talk to that later. And finally, Vivian Liu, she was my postdoc at New Mexico State. She came to us after about 6 years' experience in industry dealing with hardware circuit design, so she handled all of the circuit layout. Great. She's also a senior design engineer at Innovate Corporation, which is a data storage company. So in order to just set the scene, the background here is that whenever we're dealing with any communication or data storage, unfortunately we're subject to error, which comes from the noise in the environment. That could be things like interference in a wireless channel or imperfections in some storage medium. The way we handle that in practice to get reliable products is that we've got error correcting codes. Okay? And what they do is they add some data which allows us to correct those errors efficiently. The industry standard is low density parity check, or LDPC codes, and those are in a bunch of products that you use every day, such as your 5G data, Wi-Fi, as well as wired networks, space communications, aeronautical telemetry. Recently, they've been discovered as the primary and most promising candidate for quantum error correction and quantum computing as well. So we're excited about that. But the main reason that I'm here talking today is that we believe that our innovation is going to be particularly impactful because there's this ever-growing demand for improved performance in our systems. We want more and more devices with the Internet of Things. We want them to do more, transmit more, and we want to do that with less power. We never want to be changing our batteries, right? So we can see that if we look at this transition from 5G to 6G. So in terms of 5G, we're almost there with our key performance indicators. Not quite. We are in some parts of the country, not in others. But we can see as we're transitioning to 6G, it's going to be an order of magnitude or more demanding, which we currently don't have capacity for. And for example, you can see here we're going from, say, 1 millisecond latency to 0.1 millisecond latency, 100 megabits per second throughput to 1 gigabit per second. But the main thing I'd like to draw your attention to is the reliability. In that last bullet point on the right, in 5G, we need 1 in 100,000 frames to be at most in error after decoding. In 6G, that's going to be 1 in a billion, okay? And we really can't do that without some new innovation. So what is our innovation? Well, I think it's easiest to explain it just with an analogy of a jury or a group of people that need to make a decision on some topic. They need to come to consensus. And what happens is that one of our speakers is going to relay or discuss with his neighbors his opinion. Okay? That will continue throughout the network, and that information will propagate amongst all of our nodes. Hopefully, ideally, we converge to a solution. And that's exactly how LDPC codes are decoded in practice. It is very idealistic because often we don't have this perfect scenario, and that's the problem because that is what all of our current algorithms are built on, this idealistic situation where we converge to a nice solution. In practice, of course, what happens is anybody who knows who's ever discussed anything with anyone, you'll have differing opinions, right? So there'll be some error. For us, that means corrupted data from the channel, and that's going to then propagate through our network, getting bad decisions made everywhere, and that will happen. One of two things will happen. Either we will not converge to a solution, we won't agree on the outcome, or we'll agree on the wrong outcome. Okay? And that's what happens, and that's why our systems are limited with how many errors they can correct today. What we do in our innovation is we've got a very simple check to try to determine whether a message may or may not be unreliable. Okay, it's a very simple thresholding test. If we think the message is unreliable, what we're going to do is, we call it attenuate. We're going to make that person speak quieter in the group, right? So they're going to have a quieter message to pass on. Hopefully what happens then is as this message propagates throughout the network, and you can see that the green arrows are bigger than the red arrows, and hopefully we'll converge to the good solution, right? And that's the idea in our innovation, is to do that little test. So here's the more technical picture of the same thing. We've got noise from the channel. Instead of talking to your neighbor, we've got wires in the circuit where probabilities are passed. But the same kind of thing happens. This has gone through rigorous academic peer review in our top journals and conferences. And we've shown that we can have up to 2 orders of magnitude improvement in error performance just by shrinking the size of those possibly problematic messages. Okay. Moreover, this is applicable to both new and existing technologies. So what I mean by that is that we can take existing standards, existing transmitters, and make a small modification at the receiver and get this boost in performance. So we've done our circuit design. That's also gone through academic peer review. We've built the FPGA chip, and we show that indeed we can do this without any increase in the area or power consumption of the circuit, which is really, really neat. So in terms of applications, well, first of all, if we look at communication applications, I talked about this reduction in error rate. That's actually a trade-off that an engineer can play with. You can either say, for the same transmission power, I want lower error rate, get, say, 2 orders of magnitude better. Or you can say, for a fixed error rate, I want lower power consumption, which again may be more desirable in certain applications. The main thing where we think we've got a competitive advantage is in wireless communications. What typically happens is that the error correcting code fails. We know that, and what we have to do is we have to request an expensive retransmission. So we have a feedback, they resend the information, we go ahead and we try and decode it again. That's latency and a lot of wasted power and energy. So we believe we can make an impact there. In terms of data storage, their main problem is trying to get that very, very low error rate that they desire for reliable data. We think, again, we can make an impact there because what they do typically, because they can't get low enough error rates, is they have 2 error correcting codes, one that corrects an error of the other one. We think we can do that in one shot and reach their targets, which will give us our competitive advantage. In terms of the market, I mean, these are huge markets. We're going to try and focus here just on the specific products within those markets where we think we can make an impact. In terms of flash memory error correction, we think solid-state devices are an ideal candidate for our invention, particularly something like the VNAND SSD from Samsung that we're talking to them about. Again, why do we have an advantage? Because we think we can do this error correction in one shot rather than 2, which is very expensive. In terms of wireless communications, again, massive field, massive market, but again, we're looking at the modem products, modulator, demodulator, where we can add something to the receiver, leaving everything else, which is usually standardized, you can't touch that anyway, to get that additional performance. Again, we think that we have an advantage because we will not need as many or any expensive retransmissions. And finally, I won't labor on the last one, optical communications. Again, massive market, but we're looking at transceivers. So how do we improve the quality of the data and the speed of the decoding? Again, we think we can make a difference in those products. So to wrap up, and where are we looking at moving forward? Well, the main thing we're looking for right now is seeking partnerships with industry to develop some collaboration. We already have ongoing discussions with Samsung, Qualcomm, and Intel, and we would really like help to establish that some more. We've built our hardware prototype, as I discussed, which confirmed those promising software results. We would like to develop now a demo, maybe go through the launch program at Arrowhead and seek some market feedback and maybe some design iteration to improve what we're working on. And our last thing is that we're trying ourselves to improve what we're doing by looking at new directions. I've recently got a National Science Foundation funded project to look at machine learning to see how we can improve the decoding of these LDPC codes. And we found something really promising that we can use reinforcement learning to know when we should pass messages and who we should talk to. And that looks like that's giving us a performance power savings of about 5 to 40%, depending on the application. Lastly, we're looking at other areas where we can possibly apply this technology. One, we've submitted a proposal recently to the Department of Energy where we're looking at this, testing whether this is feasible for quantum error correction, as well as looking at cloud storage, distributed storage, and data compression, as well as cryptography. And with that, I'll wrap up. Thanks for your attention.
Thank you. Next up, we have Miko Estrada from UNM.
Tough room, huh? How you doing? Again, Miko Estrada, research engineer here at the Cosmiac Research Center at the University of New Mexico. We are a space research center, and we are under the School of Engineering. Additionally, I'm also the lead engineer of the Space Cybersecurity Lab over at the center. So I'm going to talk a bit about our space cybersecurity test bed and first kind of set the stage on the state of space cybersecurity, of the space cybersecurity industry as a whole. First off, why should you care about space? Holds a lot of vital functions that we rely on. GPS is one that always comes to mind. Additionally, in the defense and scientific sectors, capabilities like early missile warning systems, satellite imaging, and weather tracking are all very important capabilities that people rely on the ground to do. So securing those systems are paramount to the functions of those various services. At the top of the year here in January, the White House did industry perspectives on the state of space cybersecurity. Really, there's about 4 quotes here that I'm highlighting. They go into a lot of interesting stuff about the industry, so I would recommend reading this. But the 4 points that I'd like to highlight here, it really comes down to first, the disconnect between flight programs and cybersecurity teams not really aligning on what the functions of each should be. A lot of people think cybersecurity requirements are a hindrance on flight programs and on flight innovation. And so you do need both cybersecurity teams and these system engineers to be aligned in order to have a secure system. Additionally, many technologies that can be deployed are very lackluster because of the computational restraint or limitations of current space technologies, not to mention the focus on fulfilling the mission. When it comes to space, mission always comes first. Additionally, a lot of the guidelines that the U.S. government provides, a lot of satellite operators feel aren't pertinent to space systems. They're more informed by conventional IT network security rather than space or supported by space cybersecurity concepts due to lack of information, which kind of leads into my next point of many believe that information on space cyber threats is really inconsistent, untimely, not actionable, lacking context, and in some cases overclassified, meaning that a lot of these satellite operators don't really have much information to go off of to better their security posture on their space systems. So the need for space testbed infrastructure comes down to our lack of being able to definitively define the threat landscape that our space systems face, right? We can look at ransomware attacks, we can look at phishing attacks and understand what parts of the network those attack, the impacts, the potential risks that your system or your network faces. With space, we can't do that as definitively and as easily. And as we look to expand our space capabilities and networks in forms of constellations like Starlink, right? Needing infrastructure to test the future space technologies that we'll be utilizing in these future SATCOM networks is going to be paramount in order to understand if we have a viable security posture for things we're sending on in orbit in future. Not knowing the threats that space systems face also make it tough for the commercial and public industry to develop effective solutions to mitigate future cyber threats. Academia also provides very interesting ideas on how to go about attacking space systems and evaluating these systems. And really, I think having infrastructure to take these ideas off the academic papers and into a more applied environment on the real space hardware and software is going to be very important. So our solution is the COSMIAC Cave Cube. This is what it looks like opened up. It is based around the Xilinx Crea, which has a ARM Cortex A53 chip, which is used bit more in the space industry, has flight heritage, and is something of interest to people in this sector. The flight software that we utilize is NASA's Core Flight System, or CFS, which is one of the more popular open source flight softwares on the market for industry, as well as because it was utilized by NASA, it has been used in NASA missions. Additionally, ground control and simulation is also handled by NASA's NOS3 suite, which is the culmination of its flight software, flight simulation capability, and ground station capability. The onboard sensors that we have are a GPS system, a GNSS system, sun sensors, and reaction wheels that are modeled by motors, all things that are part of a position, navigation, and timing system, or PNT system, which are probably the 3 most important functions that a satellite kind of needs to make happen. The goal of the platform ultimately is to provide users with a cost-effective satellite system for cyber experimentation and easy-to-run and self-contained platform. The utility of this project and of this product really has allowed us to approach space systems engineering from a cyber perspective, identify vulnerabilities while we're integrating our hardware and software. In addition to that, our team has developed some very deep knowledge on the NOS 3 suite, and so we're confident that we can expand our testbed with commercial off-the-shelf parts in future, as well as accommodating any custom testing needs that potential partners might have down the line. We're also looking to utilize the testbed for other applications outside of cybersecurity, such as generating flight data to test AI models, as well as evaluating prototypes of mainly future software space technologies to give them a more implied environment to test their software on. The future of the Cave Cube really is we're looking to move into multi-agent simulation capability, which is very desirable to both our industry and government partners. This allows us for the research into the security of constellations, which are going to be the space networks of the future. We're looking to expand into using proper radio frequency or RF capabilities, which are the most common space communication method right now, so we can test in a more an environment that's more indicative of real space operations. We're just using conventional networking right now. We're looking to acquire and integrate new sensors for studies into more space systems and into potential vulnerabilities in those areas, as well as evaluating the impacts of common cyber attacks and malware on flight hardware and software. As far as what we're doing at COSMIAC, we are looking for new partners for cybersecurity research collaborations in all sectors of the business, so industry, government, and academia. Additionally, we're open for quotes and consultation on space testbed infrastructure. If your organization is in need of such capability, we're continuing to pursue contract and grant opportunities here at COSMIAC as we are a research center, and just continuing to foster the collaboration we have with local organizations and industry groups such as Space ISAC, which we are a member of. Outside of that, for more information on COSMIAC, because we do more than what I highlighted here today, visit our website or come talk to me after we're done here. Thank you very much, guys.
Thank you both. Before we get started to our lone and hungry shark, I mean, he's had lunch, he can't be too hungry. But I do have a couple of questions for each of you. Both of you have, David, you mentioned Samsung potential first market, and Miko, you mentioned that academia, the government stuff. For each of you, what part of these customer segments do you see has the most burning problem, and why?
Okay, maybe I can start. Okay. Yeah, so, I was invited to give a talk at Qualcomm a couple of weeks ago. I think their main concern is power consumption in the next generation devices. So I think they were very excited about that avenue, that we can potentially use our invention in that domain. And it seems like the most promising first step for us is to continue that collaboration.
Okay, great. Miko?
Yeah, so I think ultimately really in my case, right, the most burning question is really just, I would say more problem is that lack of knowledge, right? There's really not much to inform a lot of these organizations who operate space systems, especially those outside of the defense sectors that don't have access to classified information, to better their security posture. There's frameworks out there that look to kind of provide context for the space cybersecurity threat, landscape, right? That are manufactured by like the Aerospace Corporation, but those frameworks don't exactly have a ton of information that can really definitively describe that stuff, and so we're looking to really hopefully use our platform to contribute to filling in those blanks for the parts of the space industry that need it the most.
Yeah, great, thank you. So kind of on that same vein, David, you mentioned worked with Samsung. What other type of customer discovery have you done? And likewise, Miko, what customer discovery have you done as well?
Yeah, so that's a good question. So that's really where we talked earlier in an earlier panel about institutional barriers, and the biggest barrier we're finding right now is time to do that customer discovery and look at some feedback about our products. So I think that's where we could really benefit from having some more resources, maybe to employ some students to work with potential customer discovery.
Awesome.
Right on. Yeah. As far as customer discovery goes, I mean, we already kind of came into this project with a need from a customer. We were doing some contract work for the Air Force Research Labs who wanted capability like this. Not to mention a lot of other industries that we met, like through our industry partners that we've met through Space ISET, kind of also showing interest for that. So it's kind of, it started off as customer needs, and then we kind of expanded into figuring out how it can apply to the space industry as a whole. So we kind of had the advantage of not having to do that discovery, mainly because it was capability that was already sought out by people that we had active contracts with when we started this project.
Nice, yeah. What competitive research do you all see in your space that's currently going on that might you might have to uniquely separate yourself from?
Well, that's a good question. I think, you know, machine learning is hugely impacting the field of communications, hardware design, circuit design. So we're working on that ourselves, but I think that's probably where there's the biggest growth in academia, is applying machine learning to these problems. So we'll need to, you know, we're incorporating that ourselves, but that's probably the biggest competitor that we'll have moving forward, I think.
I think for us, it's, I think the growth of the space cybersecurity industry is very much on its way in the next couple years. And so as far as research goes, I think what's going to differentiate us is being able to take ideas that we formulate, right, and make them more competitive just based on running, because we run them on real hardware. Whereas a lot of papers, once again, have very great ideas, but a lot of them end in we need more evaluation or we need further testing. And being able to take that step further compared to a lot of the research that's been done already in the academic space, I think is going to be paramount and what I think ultimately separates us in the end.
You kind of alluded to it a little bit there, but for each of you, what do you feel your biggest need at this moment? Either maybe somebody in the audience can help you with, you know, is it talent? Is it funding? Is it those connections?
So for us, I don't think it's talent. So we have a lot of, you know, we're looking at mostly basic research. We've got a lot of talent at the university that we can leverage for that. I think the problem we have is that our projects are funded for basic research. There's no resources there to send students out for customer discovery. Actually, that's against what we have mandated by our funders. So yeah, I mean, I think that's the by far the biggest need we have is time to go out and speak to those customers.
I think for us, ultimately, it is funding. I think we've got the connections, we've got the talent. We are a new outfit. I mean, we were established last April, so it's really kind of finding a bigger customer base in that regard. And really, I think a lot of the funding we're to be looking for is in kind of more collaborations, things like SIBRs, things like STTRs, and things like, you know, subcontracting work with maybe some bigger primes. So naturally, with the landscape of the budget of the U.S. government right now, things are a little tough in terms of proposals right now. But I think once that gets figured out, we'll find our way there. But ultimately, I mean, we do need funding to keep the lights on and to also retain some of our talent who is going to be starting to graduate with their bachelor's degrees and either getting them to move on to their master's degree or hire them as staff, which I think ultimately labor, I've learned, is probably the most expensive part of kind of running an outfit like this.
Yeah. Correct me if I'm wrong, both of you kind of feel your technology will be adopted by, you know, a larger institution, or, you know, Miko, as you just kind of mentioned, the maybe a prime contractor of some sort that's out there trying to solve this problem, correct? Yeah.
Absolutely. I think this capability, I mean, there are other solutions on the market, but the thing is really cost effectiveness and ease of use that I think really the big service that we have, that we offer, is that everything's kind of integrated for you. We already did a lot of that legwork, and it's a matter of really starting some scripts and turn on a host machine compared to some long, like 20-page setup procedure that some other solutions have on the market. So being able to rapidly test things is going to be a very big capability, and ultimately I think solutions like ours are going to find themselves adopted because of reasons like that.
Yeah, right. And for us, I mean, our invention is a component which will be a larger part of a integrated system, right? So for us, it's licensing is where we're targeting.
And if you see, say, Samsung bringing on your technology, you see follow-on competitors likely to follow suit?
Yes, I think so. So there is a little bit of a difference between those industries. So in communications, everything's standardized. So we know what the code will be, what our circuit has to do. One of the barriers we found in initial discussions with a data storage company, I won't mention the name, was that we got so far to the point where they have a proprietary code, which they weren't willing to share with us. They wanted to see data of how well we could perform, but we couldn't do that with them. So different maybe barriers for different industries. But in terms of communications, I think that's, again, the most promising because everything's standardized. We can show how well our system performs for those types of devices.
I see. So both of these pathways, I think, look very promising. I think both of you, honestly, are looking to solve good problems. What is your riskiest assumption that you currently have if you were to continue on this path going forward? What is the one thing that you think is the highest probability of failure? Hard question, I know, I'm sorry. I didn't even give you a warning on that one.
Well, I guess I could start off. I mean, so first of all, in terms of some markets, as I mentioned, the proprietary issue is a big problem for us, right? So we've had entry discussions, but it's not really gone anywhere because we either need to, well, now we have the patent. I think that could maybe help because they can deal with it themselves a little bit. But initially, we had the IP and they had the proprietary code, and we couldn't find that balance. In terms of maybe biggest challenge, I think, is that for some of these products, the overhead that the producer makes is very small. Say on data chips, they don't actually make too much profit on them. So for something like a circuit redesign, that may be something that they would look at in future generations of their product, but maybe right now, that would be cost prohibitive for them. So I guess that's maybe one of the bigger issues.
See.
I think for us, I think more in terms of biggest point of potential failure really comes to expecting the aerospace industry to change. They're very set in their ways about flight heritage, about reliable parts, which makes sense up to a point when a lot of the most popular flight hardware is very outdated. And ultimately, like I kind of mentioned at the start of my presentation, that disconnect between flight programs thinking and cybersecurity teams, where flight programs believe cyber is just an unnecessary risk. And really, I'm trying to come at it from an angle of preventing a big space cybersecurity attack. But ultimately, I think we've been a little more reactive when it comes to especially defense-related things in aerospace, that it might take us learning things the hard way for us before we start taking things like this a little more seriously.
I'm optimistic the Air Force is looking to solve the problem. I'm optimistic. So we've kind of talked a little bit, but it's not exactly, how do you all, going forward, plan on funding additional research and additional relationships going forward? What's your plan?
So our funding has almost all come from the National Science Foundation historically. I think 3 grants now since I joined NMSU. And that, well, we'll see what happens moving forward, but that could become harder to get. I think government agencies, we're already talking to DoD about a potential grant from them related to this technology in the aerospace domain. But I think we'll continue to seek for the basic research funding from those government agencies.
Yeah, for us, we have some sources of defense funding, mainly in contracts, grants that are allocated to the core operation of our research center. And then additionally, kind of like I mentioned, we're really looking for those other contract and grant opportunities within this field. Like I said, I think SIBRs and STTRs are a good place for us to operate in, especially with STTRs, considering that requirement to have an academic partner. Since COSMIAC is a university research center, I think we more than kind of fill that requirement, right?
Yeah. Last question before I hand it over to our hungry shark. We touched on this a little bit too, but what, you need students to kind of help with some of this market discovery or customer discovery and market analysis to go out there, and the prime contractors. Is there anything else that anybody in this room might be able to do to help you go a little further outside of connections? I think it's kind of...
Well, I mean, we always need money, right? To support students to develop the product. I mean, we'll have to buy hardware for the demo. So, I mean, we're not talking large sums of money, but any kind of financial support would be helpful, of course.
Yeah, I'm right there with them. I think ultimately COSMIAC has a great talent pipeline and has brought in some very good students. I think ultimately the problem of our center is that we're finding it tough to compete in terms of like retaining students as staff. I was, lucky enough to get a solid deal, and I love working there. So that's why I am staff over there. But I think there's a lot of bright minds that come in here that we need to retain further to make our research center a leader in this area and potentially the University of New Mexico as well.
Awesome. Thank you. To our shark.
Super. So Chris, you covered a lot of ground there. That was great. Left me with very little meat, right? But David, would be great if you could share a little bit more on, as you say, this is a component, right? So it's software and some hardware at the same time, right? So as you think about these collaborations with Qualcomm, for example, how transferable is what you're building, to other providers, right? So would you have to do a lot of rework for each one of them, or is this something that can be, as you said, a standard?
Yeah, so the answer is no, we wouldn't have to, and the reason for that is that, again, we're providing one sub-circuit of a larger integrated circuit. So, and we would just demonstrate the area and power consumption that our component needs, and we've done that on the FPGA platform, so that would be transferable to other partners.
Super, and then on the, would it be capital intensive to be able to apply this? I mean, is this something, sorry, well, I'll let you.
No, that's a good question. So in terms of the manufacturer and the company, yes, that's very expensive. So they spend millions of dollars in designing their chip layout to be super efficient in terms of power consumption for all of their various components. You think of, an integrated device that's got all kinds of sensors, cameras, and all kinds of things. So that development cost is very large for them. We think that our circuit is such a small change from an existing circuit that they can keep all their layout. Actually, they just need one extra gate in there in the right place. So, and we are hopeful that it wouldn't involve extensive hardware redesigns for them.
Got it. And the reason why I asked that is just going a step further, as you were speaking about the competitive landscape and how you think about the development of AI and all these AI chips, right? If it's something that could, enhance, or if it's competitive versus those, those developments.
Yeah, so right now, our own AI-based invention and others on the market is actually, at the moment, very, very complex to implement, because what they have to do, AI produces you something offline, and then you need to build that into the hardware. That involves things like sorting, ranking, which is quite high complexity. So right now, we've got a gain over any of those solutions, but that will continue to change over time.
Appreciate that, David. And Miko, if you could share a little bit more about what's your product roadmap? I mean, what's next? Is the idea to send the cave cube into a payload, or what's next? What would you like to achieve?
Yeah, like I said, really part of it's going to be producing publications on some of the cybersecurity research we're doing right now. We are making some essentially like designer malware for this system to kind of show specifically on a microcontroller piece of it as able to lock up the system, and we're going to have it kind of act like a ransomware to show we can, what those impacts are. And so that's going to kind of, I think, drum up some interest. Ultimately, right, it's expanding the capabilities of it really from, I think multi-agent capability is where we really want to develop it to be able to study those bigger future space networks. I think we kind of have the core of the product. It's really just kind of using it for first its intended application to kind of help us publish, but also look for ways to kind of expand that out. And we're already kind of doing that. We do have some small businesses that we're working with to help generate data sets. So hopefully that starts expanding this into not just a product, but a thing that's able to provide services to the space industry at large as well.
And are you finding it difficult, or if you could share how you find your private partners to be able to get access to those data sets?
Well, we're generating the data sets because it's going to be flight data. So it's all, telemetry based on, real flight hardware, software, real data fields, information that's very indicative of a real space system. So it's not a matter of access, it's a matter of we are going to be providing the data.
Okay. And I guess finally, and going a little bit deeper into Chris's question, what type of funding or would you need, or to cover this next phase?
I think ultimately, right, because I'm not entirely sure how the venture capital world works, right, but I would imagine that, if you have investments or ties to any kind of aerospace startups, right, ideally, I think where this kind of becomes valuable is, well, first, funding-wise, SBIRs, STTRs, in terms of if you have a technology, right, more a software thing, AI model, whatever, testing it in a lab environment automatically jumps your TRL pretty, to about halfway, up the scale, right? And so ultimately, that's the kind of funding we're looking for because I think it kind of benefits everybody. It benefits us. And I think it's kind of the easiest partnership to sell, right, where it's not kind of a give and take. It is a collaboration where everyone wins in some regard.
Thank you, folks. Great work.
Thank you. All right, I'd like to open it up to the room. We have a few more minutes for questions.
For David, this is online. Are you already, or could you engage USA-based companies to leverage the CHIPS Act?
Yeah, that's a great question. So the answer is yes, and we're looking at funding opportunities through the CHIPS Act right now.
Great. And then is your team interested in spinning off a startup or licensing the IP potentially to a company?
Yeah, I think as I responded to Chris earlier, I think the startup is difficult because we're a component of this larger integrated circuit, and it's difficult for us to build even the actual component integrated circuit at the specifications that they're going to do. I mean, our technology that we can manufacture at the university is much lower than they can in the industry. So we probably would look for licensing rather than startup.
Anybody else? Going once? Going twice? All right, everybody.
That's all good. Gotta stay on my toes.
15-minute break? We'd like to do another 15-minute networking break. So see you all back here right at 2 o'clock.
So good afternoon. We are just about to embark on our final panel, and there will be a reception afterwards. So Please take your seats and welcome our quantum and AI panel. It's moderated by Jake Douglas, who's a technical business development specialist at Sandia National Laboratories, and then panel member Susan Atlas, who's an associate professor in the Department of Chemistry and Chemical Biology and the Department of Physics and Astronomy. She's also part of the Center for Quantum Information and Control and the Quantum New Mexico Institute. So welcome to both of you, and look forward to hearing about AI and quantum technologies.
Yeah, awesome. Great to see everyone here. It's been a great event today. I'm Jake Douglas. I'm at Sandia National Labs, where I lead our quantum business development team. I'm part of our tech transfer group, and I am embedded directly with our researchers, engineers, and leadership of our quantum program. So I kind of live, eat, and sleep quantum all day, all the time. I'm really happy to be able to introduce Dr. Susan Atlas. It was just stated, she's an associate professor in chemistry and chemical biology at UNM, and she's been working kind of across computation, AI, quantum for many, many years. And with that, I'll hand her the mic, and I'll join you back as soon as you're done with your presentation to moderate a quick fireside chat.
Thanks, Jake, and thanks to Rainforest Innovations and Lisa and all the organizers for inviting me to speak today. It's late in the day, and so you're going to have an exciting talk about quantum mechanics. So this is actually a little bit different from what we've heard about up till now, which has been in the nature of entrepreneurship and economic development. So I am, as has been said, I'm an associate professor at UNM, so I'm a researcher, scientist and researcher, and I am not involved in starting a company. So I'm going to talk about, this is going to be essentially a technical briefing, if you will, but I promise there's only one equation in the entire discussion. Just to give some context, given all of the excitement and buzz and, if you will, hype about both quantum and AI, subjects that I've worked in for pretty much all of my professional career, which is 20 plus years. So I want to give some context about what is really sort of behind the hype and what I see as some of the really exciting potential of both AI and quantum computing and how they can couple together. So I'll give a brief perspective on the subjects, and then I'll give some very brief examples that are a little bit technical, but hopefully give you a flavor for what goes on behind the scenes in terms of the research and the hard work of building the mathematical and computational and conceptual infrastructure that underlies everything that you read about in the news in terms of quantum and AI. So I'd like to also make a quick disclosure before I start that I do serve on the board, the advisory board of the Elevate Quantum Workforce Collaborative. So I want to go ahead and state that up front. Okay, so these are some of the students and researchers that I've collaborated with some of them over many years. Steve Alone, I want to acknowledge especially. He's been my longtime collaborator. He bugged me about getting into some of the science that I'm going to talk about very briefly today. We've had a very fruitful collaboration for many years. This goes back all the way to when I was a postdoc at Los Alamos. So I did my PhD in chemical physics at Harvard, came out to the land of enchantment, and basically never left. And it's been a great joy being here in the state of New Mexico. And as was discussed earlier this morning and this afternoon, there's just enormous untapped potential, I think, for both intellectually and in terms of economic development for the state of New Mexico. So I'm very happy to be a part of that on an ongoing basis. So these are my students. Some of them are actually undergraduates. So some of the work I'm going to talk about has been done by Sol Samuels, who is an incredibly talented person. And these are some other researchers in the group. So, first of 3 slides to tell you that stuff is not new. So, quantum mechanics is not new. All matter, and hopefully most of you have heard of this, is comprised of atoms. This is the famous Dalton hypothesis, and everything that we use on an everyday basis, whether it's drugs, whether it's materials that comprise an airplane wing, everything is made out of atoms. The properties of matter are governed by the underlying dynamics of electrons, and these are interacting according to the laws of quantum mechanics, and I've illustrated the Schrödinger equations as the time-dependent Schrödinger equation over here. And associated with all of the developments, many of the developments that I'm going to talk about today, both in AI and in quantum, are many, many Nobel Prizes. So the excitement that we have today with coming to fruition of these technologies really builds upon the foundation that was established over many, many decades. And in fact, when I was preparing this talk, I looked up when some of the foundational papers were published, and they were 100 years ago. So it's kind of an amazing thing to contemplate. So the statistical picture of quantum mechanics was put forward by Max Born. And I don't know if anybody in this room knows this. This is a fun piece of trivia. Max Born was the grandfather of the late singer Olivia Newton-John. It's kind of a fun fact, which says to me that there's some really good genes in that family. So he won the Nobel Prize for giving a statistical interpretation of the wave function squared. So in this equation, the stock in trade that you'll hear about anytime you talk about quantum is this notion of the wave function. But the probability distribution of finding an electron somewhere in space at some point r is given by the solution to this equation, and that is at the heart of describing all of the interactions between the atoms that comprise all of matter, and which are comprised in turn, the atoms are comprised in turn of electrons. The Born picture, very importantly, led just about 10 years afterwards, after the Nobel Prize was awarded, I should say, to the development, and has roots in a much older work by Thomas and Fermi at the dawn of the 20th century. But the Born picture led to an equivalent formulation of quantum mechanics, which many people take for granted now, but this was absolutely transformative, not at the start of when it was discovered, but it became an effective way of calculating the properties of interacting atoms, and thus of all matter, including molecules, everything that I talked about. This was developed in 1964 and 1965, but it didn't really come to fruition until 1993 and thereabouts. And it, again, there was a Nobel Prize awarded for this in 1998. As a corollary of what I've just said, and this is the big takeaway, quantum matter, which you will hear about, there was just a press release from Microsoft. Again, a tremendous amount of hype associated with all of this. Quantum matter, new phases of matter, none of this is new. What quantum people talk about quantum matter, it's not a new discovery. It's not something that just happened in the last couple of years. What it is the manifestation of the underlying interactions of the electrons in the atoms that comprise a material. And what happens is that seemingly exotic effects, which people then give a name to and declare a new thing that you should get excited about, are in fact manifestations of the underlying, under the hood, interacting electrons of the atoms that are bonded together in the molecule or the material. So when you hear, and this is for the entrepreneurs in the audience, that you should have a certain amount of skepticism if someone says, oh, I discovered a new phase of matter, and I'm going to cure cancer, I'm going to build a better quantum computer. You should have a certain amount of healthy skepticism about this. Not that it's not exciting. It is potentially the manifestation of new phenomena, but it is coming about. It's nothing new in the sense of the underlying physics. So that's the point that I wanted to make about that. So these are not intrinsically new states of matter, but rather, again, an emergent property of the underlying interactions. So, related to this, quantum computing, which is a consequence and a technological development that everyone is extremely excited about, which is a consequence of the existence of quantum mechanics that I just described. Quantum computing itself is not new. And in fact, Richard Feynman, another Nobel laureate, not for this, however, but very famous, many of you have probably heard of him, wrote a paper. It was actually a paper that was based on a talk that he gave that was called Simulating Physics with Computers. And this is a quote that almost any talk on quantum computing starts with this. And what he said was, because nature isn't classical, damn it. He actually said this, it's in the transcript and it's in the paper, it got published. I love it. He's from Brooklyn, I'm from Queens, very New York kind of thing to say. Because nature isn't classical, damn it, and if you want to make a simulation of nature, you'd better make it quantum mechanical, and by golly, it's a wonderful problem because it doesn't look so easy. So that notion, which was 1982, which isn't all that long ago, led to and inspired a lot of developments relating to what we now call quantum computing. And there are two pieces to this. So I have a background in supercomputing. I used to direct the Supercomputer Center at UNM. I was part of a startup, actually, in the early to mid-90s. Thinking Machines Corporation, one of the very first parallel supercomputing companies in Cambridge, Massachusetts. Very exciting time for that. And I see a lot of parallels between what we did in the 90s to develop what we now know as traditional supercomputing, that the same requirements for what we had to deal with supercomputers, we now have to deal with in terms of thinking about bringing quantum computers to fruition. And there are two sides to it. There's the algorithms, and then there's the hardware. So algorithms, I've just listed a number of them over here. You can look at them and you can see that there was this marvelous efflorescence of excitement and development of new ways to think about how to implement important fundamental algorithms, for example, like Fourier transforms, on a quantum computing architecture, and to try to understand how to effect what Richard Feynman was talking about over here, which is to say, to gain what's now known as quantum advantage. So for a while, people called it quantum supremacy. That was basically deprecated, I would say, because it dissed traditional supercomputing, and so people got annoyed about it. So now it's called quantum advantage. So the idea is, if nature is not classical, nature is fundamentally quantum mechanical, we want to solve extremely hard problems like understanding the quantum mechanics of interacting atoms, and we want to do this on a quantum computer. The idea is, can you take advantage of the underlying structure of the quantum computer, which itself is quantum mechanical, and as such has a larger phase space, if you will, for describing a phenomenon of interest. So there's a lot more parameters, if you will, that will enable you to then describe more efficiently whatever it is that you want to compute, whether it's the interacting quantum mechanics of atoms and of molecules and materials, or in this case, to have fundamental baseline subroutines, if you will, for doing important operations like search, Fourier transforms, and so forth. So these two components over here, the algorithms and the hardware, are the two intrinsic fundamental bases of doing all quantum computation. One of the things that I want to mention that is fundamental to the research that I do, and I'm not going to go into any kind of detail about quantum computing and quantum chemistry, which is one of my fields of interest, but I want to mention that one of the, quote, algorithms that's extremely important is how do you map the interactions of electrons onto qubits, which are the fundamental operating pieces of a quantum computer, analogous to classical bits on a classical or traditional supercomputer. And there are two algorithms that have been developed and used in terms of thinking about how to do quantum chemistry in a quantum computer, and I wanted to recognize them over here. One of the big challenges is whether or not we need to rethink some of those algorithms, and I'll get to that in just a minute. So the final background slide that I wanted to talk about is that the fact that I want to draw attention to is that AI, which back in the day, and I noticed that some of the speakers use that terminology, and it warmed my heart, which used to be known as machine learning or statistical machine learning, is not new itself. So this year, hopefully maybe some of you in the audience know that in 2024, just a few months ago, 2 Nobel Prizes were awarded in chemistry and in physics for essentially AI or machine learning. So one was awarded to some of the founding fathers, if you will, of contemporary AI and machine learning, Jeff Hinton and John Hopfield, who I had the privilege of hearing talk about neural networks back when I was in graduate school. And I'm not going to go through this, obviously, but this is a slide that I used in my course on applied machine learning last semester. And it is stolen and adapted from this website over here. But basically, you can see that the seeds of what we now call artificial intelligence or contemporary machine learning were sown early on in the mid-20th century, even a little bit earlier. Some of you may know that there was what was called the AI winter, which came about because AI/machine learning/neural networks in the form of so-called perceptrons was oversold. And so what happened, there was a big bust, and the neural network formulation of machine learning really could not do what it seemed to be promising to do, and so people kind of lost interest, and in neural networks in particular, and what happened was that people developed all sorts of other alternative machine learning algorithms that were not neural networks. And so when I first started working on machine learning and quote-unquote AI in the early 2000s, we were actually using these techniques, not the early neural networks. They just weren't powerful enough. What happened was that sometime in the early 2000s, really a little bit later, maybe 2006, there were some formative papers that were published where people started realizing that by inserting nonlinearity into the neural networks, you were able to then overcome the original issues that made them not so effective in being predictive of whatever phenomenon you wanted to predict. And so they became increasingly powerful, culminating finally with what's known as the transformer era, which I will talk about right now. So plain vanilla neural networks were based conceptually on pictures from neuroscience, the notion of a neuron, which gets activated and then does something. And so all of these nodes, and I'm sure most of you have seen pictures like this, these nodes, there's an input layer over here, these nodes are connected somehow, there's math associated with how they're connected, and then there's activation functions that are, again, math functions, sigmoid functions, things like that, that then operate on the input data, and then you propagate forward, continuing to do this until you get to an output. And when you do the actual machine learning, you compare the output to what the correct output should be. That's the training set. And if it's wrong, you correct it by doing something called backpropagation. You adjust the parameters of this thing. It's essentially like a big black box model. And then finally, you iterate and iterate until finally you get the best possible agreement with your training data. You declare yourself done. And that's, by the way, what people do with ChatGPT. The reason they're spending millions of dollars is that they're actually training a gigantic, gigantic model along the lines of this, except that the math inside has gotten increasingly more complex. And that is due to a paper that was published in, I think it's on this slide, yes. So this was published in 2017. It's called Attention is All You Need. And it's a little bit of a hobby of mine now, where I actually track how many citations this paper has. It has over 169,000 citations, growing constantly. It grew by about 40,000 since I started teaching my course last semester, which is kind of amazing. But what it is doing at its heart is a lot of math in that neural network, and it's trying to find ways to distinguish this from this. This is one of my favorite examples. I've given this to 5th grade students, and they come up with all sorts of really interesting things. And pattern recognition is at the heart of what modern AI and machine learning is doing, just like it used to be back in the day before neural networks really, and transformer-based neural networks in particular, came to the fore. And this has only been in the last couple of years, as many of you, again, probably know. The key thing that has made transformers so transformative, pun mildly intended, is the fact that they add context to the training process. So it's not like you're just putting in a bunch of numbers and hoping that somehow magically the neural network with some connections between the neurons is going, or the nodes, is going to magically be able to have enough information to output the correct answer. In addition to those descriptors, there is also context. This is exactly why models such as ChatGPT are so effective in machine translation. So translating one language to another. It's not that you just feed in random words and you say, okay, there's a dictionary and it's going to look it up and it's going to predict something. But rather, there's context. So I like to give the example of German, if there are any German speakers in the audience. In German, the verb is all the way at the end of the sentence. And so if you're just linearly reading in words and hoping to get a sensible translation, you're not going to do very well. So the old Google Translate, for those of you who tried it, was not very good. But now, because we have this context that's included in the modeling through this transformer idea, and what's known as self-attention or attention, what happened is that the models became considerably more powerful. Okay, so that's my background on quantum computing, and machine learning. So I want to turn now to the research areas that I think are exciting and important and potentially of interest to anyone with an entrepreneurial background or interest in this audience in particular, which is what we used to call in the supercomputing era when we were first starting to build those kinds of machines. And I worked for a company, so they were trying to sell them. So we would speak about so-called killer apps. And so the killer app, many believe, for quantum computing is the rational design of molecules and materials based on quantum mechanics. And the idea goes back to Feynman, which is that hopefully, because the quantum computer has this larger phase space and underlying interactions known as entanglement that give it a richer and more robust, in the sense of physics, ability to describe nature, that there is a possibility of dramatically, and the terms are that's usually used, exponentially more powerful in doing these kinds of predictions and doing what's known as rational design. Sometimes it's called in silico design, referring to the silicon-based supercomputers. The notion is that instead of trying to do random, basically throwing darts at the periodic table to try to design effective new materials with desirable properties, you can actually train these things from the bottom up, from first principles, literally being able to do the quantum mechanics underlying materials and molecular design. And obviously, in terms of pharmaceutical development and all sorts of applications like that, structural materials, synthetic cells, nanoparticles for drug delivery. These are all profoundly important applications that could potentially literally transform our world if we can do so. So the goal is to try to harness the underlying quantum mechanics, our understanding of quantum mechanics, our understanding of the architecture, and then developing the associated software for quantum computers, putting that all together, potentially also using AI/machine learning, and put that all together to try to discover these new molecules and materials. Our playground, I like to say, is the periodic table. So in principle, we have all of these different elements that we can play with and we can put together in novel ways in order to do what I just described. The challenge with this, of course, is, first of all, as you go deeper into the periodic table, the elements get heavier, which means you have more electrons, which means you have more quantum mechanical interactions that you have to track and also understand. And because of what I alluded to earlier, which are these complicated interactions that give rise to the wave function, which is the solution to the Schrödinger equation, or alternatively, the electron density arising from density functional theory, whichever theory you want to use to describe your system. Nevertheless, in both cases, you have to describe these underlying electron-electron interactions. It's known as the infamous correlation problem. It is an unsolved problem, and as you scale up the size of the system, whether you're scaling up in terms of numbers of different atoms and the combinations thereof, or just the sheer number of electrons in heavier elements, as you would have in structural materials, it is an extremely complicated problem, and it does not scale well. So when we think about doing quantum mechanics and atomistic simulations, if you want to do dynamics of these atoms, which you might want to do if you want to study things like fracture and dynamical effects that happen, for instance, if you hit a material or a molecule with a laser, those kinds of interactions that are dynamical in nature, all of these things require that you find some way to do this modeling. So in my laboratory, and I'm going to close by talking very briefly about some examples of applications, we are taking two approaches. One is machine learning, quantum mechanics on classical supercomputers, and the other one is the quantum mechanics on quantum computers. So first application that I want to talk about is very briefly again, we're trying to design, using machine learning on traditional supercomputers, we're trying to address the combinatory chemical complexity that we can take advantage of in order to design novel materials that are strong and ductile and are available and stable at high temperatures. So these are so-called high entropy materials. Again, we're focusing on certain component of the periodic table, the elements here in blue. This is just a kind of a conceptual illustration of what such a material might look like, and just to emphasize the fact that we're putting lots and lots of different kinds of atoms together. All of these have complicated chemical bonding, lots of electrons, combinatorically complex. What we're doing in my laboratory is we're taking this idea of clever descriptors, clever features that we can understand and incorporate into our modeling, and we are building machine learning models that take those descriptors that we've computed for simpler materials, bulk materials and binary alloys of different compositions, and the idea is to take that knowledge of the quantum mechanics, which I've illustrated conceptually over here. This is a band structure for a binary material. This is an illustration of the anisotropy of the elastic constant of the material. This is information that comes out of quantum mechanical calculations that we are now going to input into a machine learning model in order to build much, much more complicated materials. But the idea is that we're taking the quantum mechanics that we can learn from simpler materials and we're putting that into a machine learning model in order to try to design much more complex materials. So that's one example of the kind of work that we're doing in my lab. The next example, and I'm going to close with that, relates to understanding fundamental aspects of chemical bonding. And the reason I like to talk about this is because it introduces and illustrates the idea of what one of my students and I laughingly called human-aided machine learning. And it's become kind of a buzzword almost, not what I just said, but this notion of latent variables that I'm going to tell you about right now. But I first want to give you this quote from the late Steven Weinberg, again, another Nobel laureate in particle physics. You can use any degrees of freedom that you like to describe a physical system, but if you choose the wrong ones, you will be sorry. Now, he was a theoretical physicist. This was well before machine learning became a thing in all areas of physics nowadays. But the idea was that when he was formulating a physical theory, you had to think about how to put together your conceptual knowledge into a package, if you will, as a framework for then building a more complex theory. And that is the job of a theoretical scientist. It's the job of any modeler, that we want to try to understand the essence of the problem. So this is in contrast, and I'm deliberately drawing this in contrast to what some people like to think about how to do machine learning or AI, which is to build a giant database of numbers. In particular, a lot of people nowadays are doing that in order to build interaction potentials for atoms, to do classical molecular dynamics simulations, and there's been a proliferation of people building databases of carbon-carbon interactions, organic molecule interactions, refractory material interactions. Whatever problem they're interested in, they try to sample a space of interactions, do massive numbers of calculations, for example, like 13 million, 15 million, 20 million calculations of quantum mechanics, of simple systems, and then try to build a machine learning model on top of that. There's nothing wrong with that. It's great. But if you think about it for a few minutes, you'll understand and appreciate that it does not scale. Because when you start adding much more complicated interactions, or if you want to range over the whole periodic table, there's absolutely no way that you're going to be able to build a sufficiently good database for that. And I don't think that you're going to, because you're not going to be able to probe all the different kinds of interactions that you might encounter in a real material. So the question is, how can we do something that's kind of a compromise? And that's what we're interested in doing in my laboratory. So here is an illustration of kind of a continuum between purely physics-based and then machine learning-based models for doing molecular dynamics potentials. And our lab lives right over here. And we are implementing something called a latent space picture of doing the dynamics. And we're probing chemical bonding using this latent space picture. So what is latent space? In one word, or one slide, I should say, it is a learned or pre-organized deep knowledge formulation or understanding about a particular system. This is a very nice image from a recent paper where they contrast modeling a complicated system versus using a number of bits versus having a picture where you can extract knowledge about the lion. It has a mane, it has a nose, it has feet. So the latent space picture of the lion is what I just said. And it is far more informative, I hope everybody appreciates, than simply a bunch of bits that you present to a machine learning model. So this notion of pre-organizing how to recognize a lion versus a cat versus a tiger versus a dog is encoded in this pre-organization that you've established for your model. So This is a picture that we've developed for understanding chemical bonding, which also ties into how we're modeling these interaction potentials. And it's called the ensemble approach. We've published some papers about it. And the idea is that we're pre-organizing knowledge of what an atom looks like when it's inside a molecule by creating an ensemble, a weighted linear combination of atomic components. So if you have a carbon atom, you would have carbon plus, carbon minus, carbon excited states, maybe carbon 2 plus. All of those enter into a picture of kind of a pseudo-atom, which has coefficients associated with every single one of those component atomic-like species. And the important thing is that these things can be pre-computed, so that the only thing that ever changes in a simulation are the weights that are associated with each of these components. And the way that we actually build this is through a neural network. And that's illustrated here. And I'll be happy to talk to people about details if they're curious later. But the idea is that we input an electron density, and then we fit it through a neural network with coefficients that we determine that give us the balance of all the different states. And then we compare over here with what we get. And then we iterate, as I described earlier. And finally, we end up with a number of weights for the different states that are contributing at each point. And this is work, as I said, that was done by a very talented undergraduate. And it takes advantage of a very fundamental result that was developed in machine learning many years ago, which is that radial basis function neural networks, which are really, really simple. So there's a single node associated with each state of every atom in the system. This is for a simple diatomic, lithium fluoride, that these neural networks are universal function approximators. So you can do arbitrarily well as long as you have enough states. And again, the nice thing about this is that when you're doing a simulation, it's only the atomic states that contribute, and you calculate them once, and then it's set it and forget it, you're done. So I don't want to belabor this. I'll close in just a second. These are results that we got, which absolutely blew our minds. And to me, this establishes the importance of the latent space representation, which is why I wanted to show it to you. It has been an open problem in chemistry for many years. It's almost like a dirty little secret that it is incredibly hard, quantum mechanically, to describe something even as simple as the dissociation of a lithium fluoride molecule. So when you pull it apart, when they're together, if you think about high school chemistry, lithium wants to be plus, it wants to give its electron to fluorine, so fluorine can look more like neon. So that's the lithium fluoride molecule at its equilibrium distance. But if you pull it apart, logically, they have to dissociate into neutral atoms. You can't end up with an atom that has a charge on it when they're separated at infinity. So the conundrum is, can you describe that dissociation process through quantum mechanical calculations? And the answer is only with a lot of effort that would not scale in a million years to doing something like a protein quantum mechanically. So there's a fundamental issue there that is separate from just the computational effort that you might need in order to do quantum mechanics of a protein on a quantum computer. So what we found is, to our amazement, that this very simple neural network model, by reformulating how we understood the problem and expressing it in terms of these linear combinations of isolated atom charge states and excited state densities, we were able to actually describe the dissociation, which you see over here. And this is just a progression showing that as the chemistry that we used as the basis for our decomposition improved, we saw the dissociation occur. So this is going from essentially a +1 charge state to a 0 charge state for each of the atoms. We saw that as we progressed in terms of better levels of theory quantum mechanically, we actually got pretty close to what turns out to be the right answer according to very sophisticated quantum mechanical calculations, which I'm showing over here, where the dissociation is occurring and the change is occurring at about 13 atomic units, which is really far out. I mean, it's a very, very subtle effect. Okay, so I'm going to conclude here with just another remark about quantum computing for quantum chemistry. This is really the killer app for quantum computers. The goal is to achieve Feynman's original vision, and there are quite a few challenges associated with doing this. And so this is one of the things that I want to leave you with, that it's not as simple as building it, and it's not as simple as having error correction and all of the issues that you may hear about in terms of actually building and implementing a quantum computer. There's also the underlying software. But in addition to that, there are fundamental aspects to how you are going to be able to, in principle, compute the molecular and materials interactions that you might want to calculate. So in conclusion, I wanted to show again my wonderful research group at UNM and emphasize once more that there's no magic to any of these technologies. However, they are incredibly powerful. We are living in amazingly exciting times. I go to work every day just so happy that I am living through this period where all of these technologies are coming together and coming to fruition. And so I think there are some wonderful opportunities economically and in terms of fundamental research, and also in doing some real good in the world, making the world a better place through the development of new drugs, new materials, and so forth. So I hope that I've dispelled some of the mystery associated with these technologies, but also left you with this notion, which I believe very deeply, that, as I said, we are living in amazingly exciting times. So thank you for your attention. I'll be happy to take questions.
Awesome. Thank you so much, Susie. So we have a few minutes for questions, and we can go to the audience to kick things off. If not, I have one.
Amazing talk. I want to give an analogy about artificial Shakespeare, right? Where they go down, input all the Shakespeare, and then generate sonics. And it just doesn't work. And I never realized what what you're doing is so many people are just gathering data. But according to Steven Weinberg, that's not the right approach. And I really thank you.
Oh, you're welcome. Thanks for the comment.
Awesome. So I am a little curious, Susie. Can you speak a little bit to the time frames to realize this? Right. So we've heard a lot of quantum computer companies say 2028, or DARPA says 2033. Can you put a little bit of flavor behind when we might be realizing some of this?
Yeah. So I'm not the world's best prognosticator, but I'll try to put a little context. So there has been, and it was I think on one of the slides, but I glossed over it maybe too quickly. We have been living, as of let's say last month, in what's known as the NISQ era of quantum computing. So the noisy information. Noisy intermediate scale quantum era. Yeah, I'm very bad at acronyms. Anyway, so what that means is that the hardware may be there, and the models of how you use the hardware are there. You can actually do some, Google had a simple test where they showed quote unquote quantum supremacy, quantum advantage. This was in 2019, but it was for a kind of a stupid problem. It was a made-up problem, and then afterwards people from IBM, I think, and some other institutions in Japan showed that it was kind of bogus, because the quantum computing people didn't know how to make calculations on traditional supercomputers. So when people went back to the traditional supercomputers, they said, what are you talking about? It's not going to take 100 years to reproduce your calculation. We can do it in 2 minutes, and so they found an algorithm. So with the NISC era, the issue has really been noise to some extent, and it's also been practical algorithms that have the potential to beat the ones on the traditional supercomputers, let's say for chemistry. So what has changed? In the last month or so, and really over the last year, people have built what are known as logical qubits, which are comprised of physical qubits, which allow them to get more robust calculations than previously, because they can help overcome some of the noise issues, which have been the bane of quantum computers. And also, there are methods known as surface codes for doing quantum error correction. So we are very soon, I think, going to reach something called the fault-tolerant era. And I think that that's when things are going to explode. So if we truly come to the fault-tolerant era, it's hard to know because there's a lot of hype. If we come to that, then I think there's going to be kind of a tipping point, and things are going to move very fast. The question is, are we there yet? So I think that's part of it. I also think that there's been a certain naivete in terms of the people who are trying to make quantum chemistry calculations work on quantum computers. They're not often real quantum chemists, so they've sort of learned enough quantum chemistry to be dangerous, and they're very smart and they implement the algorithms, but I think that there's a certain lack of appreciation for the scaling issue and the fact that there are intrinsic errors in the quantum chemistry algorithms themselves, even on traditional supercomputers, that are going to still exist on a quantum computer, even if you do it a zillion times faster. So in terms of answering your question, I think things are going to, as I said, move quickly in the fault-tolerant era, and I have a feeling that then there's going to be a bit of a plateau, because we're going to have to figure out all of the algorithmic issues that I was just alluding to. So 2025, I would say the early 2030s maybe. I'm kind of optimistic.
Yeah, optimism is good. Yeah.
Okay, hopefully nobody's recording this. Do not make any investments based on anything I say. I'm singularly bad about this, but anyway, I answered the question.
Awesome. So maybe one more from the audience, otherwise we can.
Hi. Fascinating and sophisticated presentation. Most of it went flying over my head. I'm an entrepreneur. How would you explain quantum computing to a 12-year-old?
Oh, I don't like those kinds of questions. I've watched videos about this. I think I would, quantum computing to a 12-year-old, I would really do it in a way, I would use the first slide of my presentation actually and say, atoms are made out, all matter is made out of atoms are made out of electrons, the interactions between those electrons that are buzzing around, those are the essence of what makes your chair, you know, your medicine, whatever it is that you're interacting with. And a quantum computer is a way of speeding up how you might design such a drug or a material that is made out of the same kind of essential components as the things that you're trying to describe. That's the fine, essentially, vision. So they're made out of atoms, they're made out of trapped ions, and you're going to try to use those to describe the thing that the quantum computer is made out of. And I'll probably get a cross-eyed response. But I did successfully explain van der Waals interactions to my baby sister when she was about 12, and she still remembers it. So I had some success in the past. Yeah.
Awesome. Well, with that, let's thank our speaker for the day and pass it on over.
Thank you so much, Susan. An amazing presentation, and she's a great educator as well. Taught us all some things. Okay, we are to closing remarks, and I am delighted to introduce Brian Birk, who is the co-founder and managing partner of Sun Mountain Capital. Brian sits on all of the firm's investment committees and is a board member of Sun Mountain Capital portfolio companies, Aspen Avionics, Exogen, Green Theme Technologies. Past investments include Lumidyme. Brian is active throughout the Rocky Mountain and Southwest regions and is a current member and past chairman of the board of the Rocky Mountain Venture Capital Association. Prior to founding Sun Mountain Capital, Brian was a co-founder or senior executive at several startups, including MetaWeb, acquired by Google, Prowess Software, the BIOS Group, and Applied Minds. He also spent 6 years with the Boston Consulting Group, where he was a senior member of the North American Technology and Life Sciences practice areas. Brian transitioned from the operating to the investment side when he joined Fort Washington Capital Partners in the early 2000s. He was vice president and director of private equity at Fort Washington, where he helped to establish and manage a number of private equity direct investment funds, secondary investment funds, and funds of funds programs. Immediately after college, Brian was a trainee at the General Electric Company. He then became an entrepreneur, co-founding several startups, including Micon Corporation and Brainstem. Brian earned his MBA from Northwestern University's J.L. Kellogg School, where he graduated #1 in his class and was awarded the Austin Fellowship for Academic Achievement. He completed his undergraduate studies in economics at Carleton College. So let's welcome Brian for our closing remarks.
All right, thank you very much. I'm going to keep these brief. I know it's the end of the day, and it's been a long and a very informative day. So I promise I will abbreviate my 37-page PowerPoint presentation. No, actually, I just really want to say three things, and again, I'll be brief. I think the first thing is all of you who have sponsored a conference like this know, this conference, it represents a lot of work. The organization, the selection of the presenters, you know, on and on and on. So I'd just like for all of us to give a round of applause to Lisa, Kara, and the whole team. All right, and secondly, I also want to say thank you to the presenters and participants. You know, I thought that this event really showcased the depth and breadth of the interesting work that's going on here. And for me, personally, it was very informative, and I think like David Perez said, a lot of this was over my head, but you know, it was really a fascinating day, so thank you very much. Right. And finally, I just wanted to share a few observations from the day, and also just step back a bit. You know, I myself and my two partners started Sun Mountain Capital back in 2006. And at that time, you know, we really had this firm belief that innovation and entrepreneurs happen everywhere. And we were especially impressed with the depth of the technical resources and research that was going on in New Mexico. So we planted our flag in Santa Fe, and you know, our first investor was the New Mexico State Investment Council. That was 20 years ago, and they have remained a steadfast supporter of technology innovation and venture capital investing in the state of New Mexico. And a large part of the success that we've seen in the state is really as a result of that steadfast commitment. For us, you know, our first fund was a $20 million fund that was focused on traditional venture capital. And that fund, over the years, grew both investing here, but also investing across the region. And we have offices in Mexico City and Seattle, as well as our main office in Santa Fe. And today we're, somewhere around, I can't remember, maybe 600 or 700 million assets under management, all told. But it just goes to show that you can have success here, right? And I think personally, right now is the best time that I've seen in 20 years to be an entrepreneur here, right? And for a whole bunch of reasons. The number one is, again, the State Investment Council, over the last 2.5 years, has committed over $700 million to 22 venture capital funds to specifically invest in startup companies here in the state. I mean, that's an incredible commitment, and something that, as an entrepreneur, knowing that if you've got a solid business plan and a good idea, that there will be capital, right? That part of the equation, assuming your pitch is compelling, right? That part of the equation is not as difficult as in many, many other states. So number one, there's a lot of capital here. Number two, what I see is that the VC investing world is oftentimes driven by thematic investing. So people like AI, or they're into oncology vaccinations, or whatever it might be. And right now, some of the major themes that exist in VC investing are very strongly aligned with what we do here and do really well, right? It's the hard science, deep tech, early stage stuff that was out of favor for almost the last decade. Everybody was doing SaaS software. But no, the world changes, and somewhat driven by AI, but also driven by the fact that the SaaS software is kind of been there, done that at this point, and now people are getting back to real, true science-based innovation, and this is where New Mexico is really strong. I was the chairman of the Rocky Mountain Venture Capital Association. I've seen every state in our region, and I can tell you that the startups I see and the technology I see there, we compare very favorably. And so we should be very confident in the work that's being done by, you in this room, but also across our universities and national labs. Finally, let me just say that the VC ecosystem here in the state is rising. We heard David Perez made a mention of the increase in deal flow and the dollars investing. And believe me, when we started this in 2006, if we had a year, or even a combination of 2 years where we hit $100 million in investing, people we were high-fiving, right? We were going, wow, can you believe we had $100 million? And in the last few years, we see single companies raising $100 million rounds, right? And years are typically double that or triple that. That's an amazing amount of progress in the VC world. You don't measure progress in the VC world in months. It's really years or almost decades. And I've seen this true wave of activity and financing and entrepreneurs and ideas that makes me think the tide is really rising here. And so, so I'm really thrilled to see the progress that's been made. And finally, I'd just like to leave you with just a very brief story. I found the presentation on machine learning was a particular interest of mine because way back in 2006 and a half, one of our first investments was in a company that used rudimentary machine learning that had been developed here at the University of New Mexico. And the original application of that machine learning was to identify they identified a certain relationship amongst different parts in a component that, based on that relationship, they could actually effectively predict failure rates for the part. So they knew when things came off the assembly line, even though they looked completely perfect to the naked eye, based on a set of quality testing, they realized, oh, well, these parts, because of who knows what reason, but these parts are much more apt to fail, and lo and behold, they were. So a researcher who was working here part-time kind of dabbling in the lab but really looking to start her own company. Her name was Dr. Juanita Tuttle, and she went on to start Tramway Ventures. Dr. Tuttle looked at this and said, I wonder if we could use this to look at the human genome and predict certain genes that fail or genes that create disease states. And the first target was breast cancer, right? And the long story short, the model that she developed, we ended up, as most startups do, pivoting once, pivoting a second time, but the third time, it became a great success, and in fact, IPO'd on the NASDAQ a few years back. And the company's called Exogen Diagnostics, and it started right here at UNM. So with that, go forth and conquer. Thanks.